Good morning, everyone. On
Good
behalf of
morning.
ANRCM, I welcome you all to the second day of the National Training Program on Soil Health Management Concepts and Practices. Uh, so we will be starting the technical sessions of the today's training program. We have back-to-back several lectures from eminent scientists, especially soil scientists, working in the field of soil health management. I request every participant to keep their microphone mute during the session. Whenever there is discussion, you can participate in that, or you can write your queries, if any, in the chat box. Also, put your attendance in the chat box as by means mentioning your name. Those participants who have not named their means on the Zoom, they should name it. Otherwise, we will not edit. We will not be able to identify who is present. So I request Dr. Pradeep Kumar Rai, course director of the training program. Suman Kashyap, please mute yourself. Suman, because your means the disturbance from your side will create problem for the other participants also. Please avoid that. I request Dr. Rai, course director, to kindly initiate the activities of the today's program.
Thank you. Thank you very much, Dr. Arora. Very good morning to all and happy Navratra. Now, today, the first lecture will be delivered by Dr. Vikas Sharma, and he is the professor in Division of Soil Science and Agriculture Chemistry at Sher-e-Kashmir University of Agriculture Sciences and Technology of Jammu. He completed his doctorate from Punjab Agriculture University and postdoctorate from West Virginia University, USA. His research interest includes organic farming, soil carbon, soil and water conservation, land degradation, remote sensing, and GIS. He has over 70 research articles, 30 book chapters, and 6 books to his credit. He has been instrumental in establishing the Organic Farming Research Center at ISCOS, Jammu. He is part of the technical working group of Jammu and Kashmir government farming policies for promoting organic farming in the region, as well as for farming the land use policies. He is part of the prestigious group working to make Palli the first carbon neutral village of India. And he has very vast experience from working in northwestern Himalayas to the plain area and Tarai belt. So now I request Dr. Vikas Sharma sir to kindly deliver his talk on organic farming and soil health. So Vikas Sharma sir, please.
Straight away to the presentation. Please allow me to share my screen.
So you're already allowed, sir. Please.
I hope it's visible now. डॉक्टर साहब
Yes, it is.
और ठीक है और चल भी रही है
जी,
मूविंग है ना?
यस सर,
ठीक है, थैंक यू. Good morning, everyone. as already informed, I'll be talking about organic farming and soil health. Dr. Rai, किसी की noise आ रही है काफी.
All participants are requested to kindly mute themselves so that there will be no hindrance in the presentation.
डॉक्टर राय, आप जैसे डॉक्टर सूरज माली की अभी डिस्टरबेंस आ रही थी, आप उसको लेफ्ट में उसके बटन को आप एक बार म्यूट कर दीजिए, कोई बात नहीं. हाँ, यस.
Okay, thank you, Dr. Rai. Good morning, everyone. So to start with about organic farming and soil health, I'll be talking a bit about soil health in the beginning, and then we'll see how organic farming will help us in maintaining the soil health and the sustainable nature of our agriculture production systems. So we have talked a lot about these things recently, and you might be aware that soil health is a very big concern nowadays when we talk about agriculture production. Although it's a very big concern, although it's a very big concern, but you might have noticed that when it comes to extension activities, we talk very little about soil health. Although soil health card scheme is very active in different districts of India. But still, the focus is largely on other things, and soil health is largely ignored in many of the meetings. It's something like air quality when we talk about air, because these things are actually free. And when something is free, we don't give it much of a emphasis. Like only when we started talking about air quality, only when we saw the air quality index rise to very unacceptable and unbearable levels in New Delhi. Likewise, we also started talking about soil health in the 90s when the pressure increased, but still at farmers level, very little effort is being made or done to talk about soil health. And we have seen that over the time when the health of the soil has deteriorated. So organic farming is one such solution which will help us not only in producing quality food that we direly need nowadays, because there's a lot of chemicals and hazardous material coming with our food grains and vegetables, etc., which we are consuming on day-to-day basis. So not only that will be taken care of by organic farming, but soil health will also be restored. So soil health, soil quality, and food quality all can be taken care if we adopt organic farming. And this, of course, will help us in improving the human health and soil biodiversity. As you know, they are all linked. So if we go back, as I was saying, that we started talking about soil health in the 90s, soil quality in the 90s. It is not something that our Dr. Sarath Kumar and Dr. Ganesh Chandra, kindly mute yourself, please. So it's not something that our ancient people didn't know about it. When we talk about Vedas and other ancient texts in our thing, then we see that this has been always mentioned. And that civilization has always come around, and we have talked about water, that whenever a civilization arises, it is mostly around the water. But it's not just the water that we talk about here. It was also the agricultural land adjoining those rivers that was very fertile, because the agriculture was the main occupation of any civilization in those days. And they came around the areas where there was enough water, and along with that there was quality soil. And of course the population at that time was very minimal, so the people moved from one place to another place so that they can have fertile soil continuously. So soil health issues that we face nowadays are when we talk about all this, soil health assumes greater significance, and we know that indiscriminate and unbalanced application of fertilizers in the conventional farming system is Dr. Rai, can you just mute everyone? There's a lot of disturbance coming.
All are requested to kindly mute themselves so that.
Please use the function where people can't unmute themselves.
ஏன்னா பெரும்பாலான பகுதியை அதுக்கு செஞ்சுட்டாங்க பழைய சாப்ட்வேர்.
I mean, someone or the other is always. मेरा lecture है यार. Okay, so indiscriminate and unbalanced application of fertilizers, rampant soil loss is occurring, especially in the hills. Then there's a lot of salinity that is emerging in these areas. For example, if we talk about my area of study, that is in the northwestern Himalayas and adjoining plains, we see that a lot of soil loss is happening in the lower Shivaliks, where the agriculture is taken up and where the lands are basically bare of any forest. A lot of soil loss is occurring. So now that soil loss is not only occurring there, the soil that is lost is coming and settling down in the low-lying adjoining plains. Now this settlement of soil there is also responsible for water logging in the plain areas, and which is ultimately resulting in the salinity. So carbonates are coming, which are promoting salinity in these areas. So you can see that everything is actually linked from the type of farming that we are practicing and the type of problems we are facing. They're all linked together. So keeping this in mind, in 1990s, the soil quality concept emerged, and both soil health and quality terms are now being used many a time synonymously. Of course, a lot of effort has been made by the soil scientists to differentiate these two terms, but I feel that they are more or less similar, although there are specific definitions for both of them. But in general, if you see that soil quality is something like a functioning of the soil when we talk about different parameters and generally given in terms of numbers. But when we talk about soil health, it's more of a general idea about the soil. It talks about biodiversity, soil carbon, and a limited set of parameters. But you can say you can link soil health and quality together. So soil quality is the continued capacity of soil to function as a vital living system. Okay. So it is something that has to be functioning consistently, and it recognizes that it contains biological elements. So something that we have overlooked for years is the biology of the soils. We had been mostly worried about the chemical properties, pH, AC, NPK, nutrients, but we have consistently overlooked biological elements. Of course, there are studies, but the you can say the efforts that have been made earlier were limited to the chemical properties and to certain extent the physical parameters. But of course, now we are recognizing it, and almost all the studies include biological parameters. So all these are the key to ecosystem functioning. So this was the definition given by Doran and Zeus in 2000, and then Carlin modified it in 2001. Apart from soil health and soil quality, nowadays a new concept has also come, which talks about soil security. So this is not only limited to producing food and fiber and fresh water as a filter system, but it also talks about contribution to energy and climate sustainability. You are all aware that soils have a big role to play when we talk about climate sustainability and a solution to climate mitigation. When we were working around the Palli village, we saw that even 0.1% increase in soil carbon can significantly enhance the total carbon dioxide or total carbon sequestration and carbon dioxide conservation in the soil. Then another important point is the maintenance of biodiversity. Although we know that the soils were very important for producing or sustaining plant growth, whether it be trees or agricultural crops, but very little linkage was created between maintaining the biodiversity of the area and the loss of biodiversity due to loss of soil. For example, in the Shivaliks, we see that wherever there is a lot of soil erosion, there is land degradation. And when there is land degradation, we see that the vegetation is very, very limited. And that is also affecting our biodiversity as well. And to protect our overall the protection systems, we need to have a sort of a protection system for the soils so that the biodiversity in turn is also protected. So this is the new term that is referred to as soil security. So it is concerned with the maintenance and improvement of the global soil resource to produce food, fiber, and fresh water, to contribute to energy and climate sustainability, and to maintain biodiversity. Then we come to the sustainable development goals of the United Nations. Soil health has a very important role to play in this soil health in these sustainable development goals. Although none of the goals are actually, if you see the draft, they don't actually refer to soil health directly, but many of the major goals of the United Nations has something to do with soil health. So number one, like food security. If we talk about food security, this cannot and is not possible if we are not talking about soil health. You know that the capacity of soils to produce has sharply declined over the years. That is mainly due to the declining or deteriorating nature of the soil health. Then again, water scarcity, soil is very, very important. Whether it be the filtration that the soil does for us, whether it be the storage that the soil does for us. And then, of course, climate change, which I just talked about, because carbon sequestration and all that can play a major solution to the increasing carbon dioxide levels in the atmosphere. And then biodiversity loss, we talked about, and the health threats, because many of the health threats, you know that we talk about the cancer train that is moving from Bathinda to Bikaner. We talk about many other issues that are rising. Many other issues that are rising in humans, which are closely linked to the soil health, because you are all aware that the population of a certain area where a production is directly dependent upon the quality of the food. So their health is directly related with that. And nowadays, due to our food distribution system, now this thing is also expanding to other areas where such issues were not earlier existing. So the conventional technologies, we are not against conventional systems because this is something that has helped us in increase the food quantity and food production in India. It has helped us in sustaining the population. We have increased our food grain production to a very high level. I think it's about 300 tons. Nowadays, we are talking about food surplus. We are talking about surplus management. When we see in the 70s, where there was a big deficit in the amount of food required, and the population has also increased since then, and so has the food production, and we talk about surplus management. But across the way, we have seen that although we have achieved so much when it comes to, we have seen that there is a drastic deterioration of soil health due to the intensive practices that we have been following, especially in certain states like Punjab and Western UP, where very intensive agriculture has been was adopted. There is a drastic decline in the overall quality of the soils. Then we have increased erosion and loss of natural fertility of soil. Now, this is largely related with the adoption of agriculture in areas where they were not capable. So land capability classification is very important. So in mountains and mountainous zones where people are adopting or encroaching on the forests to meet their agricultural demands. So this is very rampant nowadays. Then again, poor response to fertilizers. Many of the studies have revealed that we need nearly 4 times more fertilizer to to produce the same amount of grain that were once produced in the 70s. So you can see the quality of our soil, how far below it has gone. And then if we go away from soil health, and there was sudden and frequent appearance of new pests and diseases also linked with conventional technologies and intensive farming and a very stagnant and never changing crop rotation system. So you see that pests and diseases are also, you can say, becoming very resistant to the type of pesticides that we have been using. Then, of course, reduction of biomass production is an important part of this. And finally, the environmental pollution. As you are aware that we are using a lot of synthetic chemicals and fertilizers. Not everything is going into the food material itself, but we are also polluting our water bodies. For example, nitrate pollution in aquifers, phosphorus pollution in our ponds and lakes. So all this is directly linked with the conventional technology models. So this is the decreasing response to NPK in India. You can see how it has been declining. Then adverse effects of synthetic fertilization. Some of these things are acidification. When we are using a lot of nitrogenous fertilizers, we see that a lot of acidification is happening in many places. Then salinization is a big problem in many parts of India, especially in the flat plains of Punjab, Western UP, even the southwestern plains of India, and many other areas around the country. And then microbial exhaustion is one important effect of synthetic fertilization, and we'll see how it is happening. Then limited nutrition, because we never talk about potassium application, even though all our recommendations in all the SAUs talk about NPK in a combined manner, but we have seen on the ground that farmers rarely go for the application of potassic fertilizer. And we see that there is an 8 to 10 million tons of potash deficit in the soils that is occurring due to this. So it is a sort of a mining that we are doing, because we have minerals that are rich in potassium in these areas. But we can say that over a period of time, we have really mined these soils, and we may need soon need application of fertilizer on a compulsory manner. Then we have fertilizers that leach readily, like nitrogenous fertilizers. When it's converted to nitrogen, we see that there's a lot of leaching, and then there's a lot of volatilization as well. So both air and water is polluted, and eutrophication is caused by mostly by phosphorus when it moves along with the eroded soil into the water bodies. So apart from that, we have seen that in the 1950s, we were talking about only nitrogen deficiency. You'll be aware that most of the Indian soils are deficient in nitrogen throughout the country, except in some temperate areas where nitrogen is in the medium range. But in most of the regions, you'll see that most of the agricultural lands are deficient in nitrogen. But over the years, we have seen that there have been emerging deficiencies in many of parts of India, especially when it comes to micronutrients like iron, zinc, manganese, and boron. Apart from that, we have seen deficiencies of sulfur. Even in the place where I work, we've seen that zinc has been one of the main deficient element here. And then in the rain-fed areas, we have also noted that boron and sulfur deficiencies have also arising in these areas. So I was talking about microbial exhaustion due to application of synthetic fertilizers. So nitrogenous fertilizers have a major role to play here when we talk about microbial exhaustion. And generally, it is perceived that whenever discussions come up and we say that फॉर्म तो सेम ही है जो क्रॉप ने लेनी है. सो इट इज ऑलवेज नाइट्रेट दैट प्लांट हैज टू बी टेकन अप, चाहे वो ऑर्गेनिक मैटर से मिनरलाइज होके आए या चाहे वो यूरिया से, अमाइड से, अमोनिया से नाइट्रेट बन के आए. So this is generally a part of the discussion that is generally happening. So but the difference here is that organic material releases these elements very slowly, and in sync with the requirement of the crop. But in case of nitrogen or urea application, what is happening is this rate is very fast. And as you are aware that the usage or requirement, or you can say efficiency of such fertilizers is only 30 to 40%, and that too that we talk about in textbook material, that it is 30 to 40% efficiency, and that is based upon many experiments that are conducted. But when we go into the real world, I'm very sure the work of Dr. Vijay Singh and Dr. M.L. Jad, who has worked extensively on this, that the actual real world efficiency is even lower than what is written in our textbooks. So what is happening is that extra amount of nitrogen that we are giving is actually creating all the problems in the soil. So what is happening that the activity of nitrogen is also sort of a food for microbes. So the activity of microbes increases drastically when we apply these and resulting in their exhaustion. So they quickly burn out. There is lesser carbon. So when they get a lot of food, their activity increases. That means they require carbon. So now this carbon comes from organic matter, which is rapidly decomposed by them. So we are also losing the organic matter reserves, and we are exhausting our microbes also. So what do we seek now that we know what is the problem? So what we seek is a sustainable production system. We know what is the problem. We have been talking about it for a long time. We need a sustainable production system that produces healthy food, that does not destroy our soil biodiversity, that reduces carbon footprint. And good thing about this is that both, if we preserve carbon in the soil, it does not only improves the soil fertility and soil biodiversity, but it will also help us in mitigating climate change. So it's a win-win situation. So if we take care of soil fertility, we can take care of climate change. If we are taking care of climate change, we are also improving our soils at the same time. So organic matter is directly linked with soil health, as I told you, and they are all linked with the climate change. So one of the major components of the organic farming that is related with the health is the addition of organic matter. So we see that organic farming talks about the addition of organic matter in different forms, whether be green manuring or organic manures. But this organic matter has to be in sufficient quantity. So because our goal is not to just enrich the soil and provide for the crop requirement. So we are talking about both sequestration and as well as feeding the crops as well. So both these needs have to be met. So this will ultimately lead to carbon sequestration. And retaining carbon, as you know, is a major solution to decreasing CO2 levels in the atmosphere. So why we talk about sequestration? This is just something that I put here because we have already released, you can say, around 1,000 gigatons of carbon dioxide to the air, and we have a budget of nearly 500 gigatons of carbon dioxide without affecting the temperature that we have now. But if you see what we have in reserves, on the orange profile, if you see 745 gigatons of carbon dioxide is already reserved for different gas companies.
5.0 40 into 0.02 0.8 gram.
So 745 is already reserved. So if that is also released in the coming years, then a lot of temperature increase would be happening. And another 2,000 gigaton is estimated reserves, which are yet untouched. So you can see how much effect this will have to our environment in the coming years. So then it comes to the thing that whether the soils should be a source or a sink. There's no doubt about it that soils have to be a sink for carbon and not the source. Till now, the soils have been a source to carbon. we are rapidly converting forests to agricultural lands, and then the agricultural lands are further degrading. So the carbon is being lost over the years. And one of our studies in the Shivaliks have revealed that the carbon storage in the adjoining agricultural and forest lands is almost half in case of agriculture, in less than half, which we have studied. So if we have seen that over the last 50 years, the land was converted to agriculture, and we have seen that the carbon stocks have rapidly gone down. And we have also noticed that the degraded soils and the agricultural soils are now almost at the same level of carbon stocks. So what we need to do is we need to convert and follow agricultural systems that make soils as a sink for carbon and not otherwise. So loss of soil carbon, land degradation is related with that. Then soil organic matter reduction is related with that. Water storage is related with that. Loss of biodiversity is related with that. And when the carbon is going down, there's an overall decline in soil health. So soil health and quality is dependent upon various properties. Organic carbon is one of the major indicators of soil quality, apart from other biological, chemical, and physical properties. We'll not go in detail about these, and we'll see how we can increase soil organic carbon. So by enhancing plant residues and root inputs to the soils. And one thing here is very important, that whenever we talk about agriculture, it's not that agriculture is totally deteriorating the soils completely. It is a type of system that is deteriorating the soils. In areas where there was no earlier cultivation and we have taken up cultivation there has been an actual increase of organic carbon, because plants are also providing biomass to the soil. The roots are always retained inside the soil, so that is helping increasing carbon content. So increase, but we are never returning the residues, so that part has to be taken care. Then increasing the quantity of organic inputs, so less dependency on synthetic material, more on organic matters as much as we can get. Then reducing decomposition losses through minimizing disturbance of soil. So reducing disturbances, reducing tillage is also another goal by which we can increase organic carbon in the soil. So organic farming is one such system that can help us in restoring the carbon that we have lost to the soil, and also supplying with us with quality food material. So this is a production system not only related to crops, but also animals and other products that do not use synthetic chemical fertilizer and pesticides, that are not using transgenic species or antibiotics and growth enhancing steroids of any kind whatsoever. So if we put conventional and organic side by side, we'll see that in conventional, we are applying chemical fertilizers to promote plant growth. On the other hand, in organic, we are using natural fertilizers, or what we call as manures or compost, to feed the soils and plants. Then in conventional, we are using synthetic insecticides to reduce pests and diseases. Then on the other hand, we are using only natural pesticides, what we call as biopesticide or bioformulations. Then we have traps for the insects and other biological means by which we can control pests and diseases. Then for herbicides, to manage weeds, we use synthetic herbicides, but in case of organic, we are using organic compounds, and hand weeding, of course, is very important. In fact, I'll share with you my practical experience. We have been able to provide nutrients under organic. We have been able to control pest and diseases under organic using different bioformulation. But one of the major challenges that still remain in organic, and that what we have seen here, is the control of weeds. So we are working on it. Some of our new studies have been successful in controlling weeds significantly. But manual weeding will still remains a major. Then when it comes to animals, we are using antibiotic, growth hormones, and medications. So this cannot be a part of an organic system. We have to be dependent on the quality of the fodder and all those things for maintaining their health. Now, in organic versus conventional, we see there are two different approaches, totally different approaches. When we talk about traditional or conventional systems, our target is feeding the plant. You might have seen package of practices where we say, okay, for basmati rice, this is NPK requirement 30-20-10. For rain-fed maize, it's 60-30-20, and so on for different crops. So our target is what is the requirement of the crop. We are not talking about soil health, nothing. So this much nitrogen is required by maize, this much we are going to apply. So that is clearly written in. So this is a direct approach that is based upon the feeding of the crop. But in case of organic, the idea is not to feed the crop, but to feed the soil. So what we are doing in organic is we are making the soil healthy, and that in turn will feed the plants.
Same slide.
So this can be explained further by this slide, similar slide. So organic fertilizers and chemical fertilizers. So you see that chemical fertilizers are directly the plant nutrients that we are applying. So we are directly feeding the plant. So microorganisms go out of the picture, and whatever excess fertilizer is, that microbial exhaustion is also occurring. So double impact. But when we are applying manures and other bioformulation, what is happening is we get the soil nutrients, but microorganisms play a major role in providing these soil nutrients. So my soil biodiversity also increases, and then we have plant nutrients, and then taken up by the plants. So organic farming is a system of production that relies on animal manures, crop residues, organic waste, aspects of biological pest and control. In this on-farm management system, nutrient management is looked after by crop rotations, multiple cropping systems, mixed cropping. And then we have to incorporate legumes as intercrops or in the crop rotation. Then we have crop residue management by use of on-farm made. Let's skip this one. So the first and most important target here is converting to organic farming. And this is also a very critical time, because the conversion period is the most stressful period for a farmer, because he will definitely face the challenges when it comes to reduction in the yield of the crop. So what we talk about is that we have to raise the organic carbon first. So this is actually raising the organic matter. So this has to be beyond 1%. Actually, it should be 1.5%, but for our Indian soils, this value has been reduced to 1%. But if it goes beyond 1.5%, then the soil itself will start feeding your crops, and the yield will be restored eventually. So this is generally the target, that we have to take it beyond 1%. You doing organic farming on soils which are very low in organic carbon is generally not recommended. But over a period of time, if we use this prediction, then we'll be increasing the organic carbon in the soils. So sometimes what we do is we convert, as I was talking about, that feeding the soil and feeding the crop are different things. Sometimes what we do, okay, we can convert this recommended dose of fertilizers into how much organic manure. So that is not how it works, especially in the beginning when we are starting with organic farming. So you can see a figure here. So this is like around first 3 to 4 years of the period where your yield will decline, where the quality will not be that great, and where the soil carbon sequestration will be very, very limited. So initially it will take a lot of energy, time and resources to increase that soil carbon. After 3 to 4 years, when initial base is set, then we'll see a exponential increase in soil carbon before settling down again. So this is a very crucial period for the farmers. And once this happens, we'll see there's a better aggregation. Now there'll be water and nutrient retention will increase. Air and water quality will also increase around. And finally, of course, productivity will also increase. But first 3 to 4 years, the productivity will be very, very low. It will take off only when these parameters start improving. So what are our options for conversion maintenance of soil health under organic farming? We have green manures. This is very important. We have animal manures. We are also talking about compost and vermicompost, especially vermicompost is very popular nowadays. Then crop residue management is very important, both from environmental as well as retention or of nutrients to the soil. Then of course biofertilizers. Also we talk about very limited use is occurring when it comes to biofertilizers, but they are very important. So first we'll be talking about green manuring here. So in a nutshell, I can say that green manuring is very important, and our experience of using Dhencha as a green manure in a rice wheat system has ensured that we don't need to apply any nutrient other than the green manuring that we have done before the paddy crop. So Basmati itself is a low nutrient requiring crop when compared to hybrid or high yielding rice varieties. So what we are doing is we are taking Dhencha for 40 to 45 days before Basmati, taking up Basmati. So after that, we are not applying anything. This time our crop has been very, very good. And we just had one spray of vermi wash after 30-35 days. And there was no other manure was applied to the crop. So you can say that how much nutrients green manuring is providing to the crop. So this is how we are doing green manuring. So around 40 to 45 days after we go for green manuring. Generally, this many times what farmers are doing, they are doing green manuring, but they are giving certain amount of time to transplant the paddy. But we recommend that it has to be done as soon as possible, because once the green manuring is incorporated into the soil, the nitrogen stored in the nodules start releasing upon the death of the plant. So the earlier that we go for transplanting, the better you can say returns will be obtained from the green manuring process. So this is the dry matter and unaccumulation by different green manuring crops. You can see that 133 kgs, this is in kgs, is accumulated. This is the nutrient content on air dry basis for Sunham, Dhencha. Okay, then we come to the crop rotations, including green manuring within the within a cropping system is also a sort of a crop rotation, but we talk about it in terms of green manuring because it is a it's a type of crop that is not giving any returns in terms of in physical terms, you can say, to the farmers, but we have seen that most of the farmers here now are not taking green manures at all. So if they want to have something in return, so we talk about in terms of crop rotations, we can go for pulses, leguminous crop rotations. Then apart from green manuring and crop rotations, we have bulky manures like farmyard manures. You are all aware of that. We have sheep and goat manures. We have poultry manures. Farmyard manure should definitely be a part of your production system, even though you have other options like green manuring and especially in the early years, other options like vermicompost is there. So in the early years of organic production, organic farming, farmyard manure should definitely be a part of your production. At least 50% of it should come from your farmyard manure, so that this will help in building the organic matter content of the soil. Other manures like sheep, and that depends upon where you are, what is the availability of these manures. In the hills, mostly the cow dung, and this is very limited, and sheep and goat rearing is much common, so that can be done. And then poultry manure is also, it has different properties. We don't recommend it that you entirely depend on poultry manure, but a 20 to 25% of your total nutrient requirements can be managed from this, or alternately from cake like neem cake. So we have seen that neem cake and poultry manure, they have high nitrogen content, and what we see is that having 15 to 20% of nutrient requirement met from poultry manure or neem cakes can help in actually controlling the soil-borne diseases because of their very warm nature. So this will help in controlling soil-borne disease, and is a good practice to involve application of neem cake in at least in one crop during the year. So this is about composting, how we can do it. You are all aware of this. We need to have trenches that are 4 to 5 meter long and not very wide, so that we can manage, generally 1.5 meter to 2 meters, and around 1 meter to 2. This is regular composting and not vermicomposting. Here we put farm waste layer by layer mixed with cow dung slurry of water, and then these trenches are filled up to a height of 0.5 meter above the ground. But this is nowadays followed, is not very much carried out by the farmers. They are more dependent upon vermicompost, but still this is very important, and this can be enriched with nutrients like phosphorus and nitrogen. So additionally, we can add N-fixing and P-solubilizing cultures to these compost that will help in improving the N and P availability in these composts. Then vermicompost has become very important over the time, and this has been very very easily adapted by the farmers. Where we have gone, the farmers are really, because this is relatively easy to do. Earlier we used to have brick vermicompost units having a shed, but nowadays we have very disposable type of vermi, and I've seen many farmers actually doing it on a rough, you can say, a surface without any enclosures also. So it has, the cost of having a vermicompost unit has declined significantly, and the farmers are all for it. And then it can also we can also use crop residues, almost anything there in the vermicompost pits. So the different phases of vermicomposting: one thing is collection of waste, then pre-digestion for 20 days by heaping the material, then there's preparation of earthworm bed, then there's collection of earthworm after vermicomposting, and then storing the vermicompost in a proper way. So what we need is a hospitable environment. So we have to maintain 50% water content, and we have to keep moving from time to time. And then adequate aeration should be there, protection from temperature and extremes. So it gets very warm in a compost pit, so we have to what we call mix the compost again and again, so that temperature doesn't increase. And one thing here is very important, that worms will stay only as long as they have the food. Once they have completed their job, they'll move down, and there has to be a strong surface. So we cannot have an open type of soil below, otherwise worms will move into the soil. So we need a surface. It can be made of even clay also, so that the worms cannot go below them. So this is the nutrient content of the vermicompost. And another important aspect is crop residue management. We have seen that there's a lot of burning of straws, paddy straw, wheat straw, especially paddy straw, because the time that the farmers have between sowing of wheat and paddy is very, very limited. And due to the you can say what we call as the immobilization process, the quality suffers in the initial years. suffers. So burning the residue is much easier than incorporating the residues in the soil. So farmers are basically adopting. Of course, a lot of work is being done on this, especially when it comes. You might have heard about Happy Seeder and Super Seeder. So these are the type of equipment that has been promoted by different agencies in different states, so that residue can be managed. In case of organic farming, if you see that we are actually retaining the residue in the soil there itself, and it is being poured into the soil. We don't anything go out of the system, and whatever the straw is actually coming out, it is either being used in the vegetable.
सर, डॉक्टर विकास सर, आपकी आवाज नहीं आ रही.
हेलो.
हाँ सर, अब आ रही है आवाज.
आ रही? अच्छा, मेरी नहीं आ रही, बाकी सबकी आ रही.
It's okay, sir.
अच्छा, so okay. So recently we had a seminar on this burning issue. It was seen that the nutrients worth 3,000 rupees can be incorporated per hectare into the soil if this residue is not burned. So if we have technologies and we can make farmers aware of this, so it's a win-win situation. We are also incorporating the residue into the soil. The carbon has increased where we are incorporating this, and we are not releasing carbon dioxide into the air as well. So it is a win-win situation. The only problem is the time between the paddy harvesting and wheat sowing is very limited. Recently, we have released a very important variety 118, which is basmati variety, and it is maturing around 18 to 25 days earlier than the basmati variety. So that is also something that we can think about.
अरे आएगा तो यहीं पे तो आएगा, बैल बजेगी, तुम्हारे सामने ही तो रखा है.
Then biofertilizers, of course, these are very low cost. They are low capital intensive. We don't have to invest much in that. Non-bulk, they are very eco-friendly, and they are very suitable for marginal farmers at least. So we have different categories of biofertilizers. We have N-fixers that are Azobium, Azotobacter, Zoospirillum that are commonly used. We have pea-solubilizing microorganisms, fungi and bacteria both. We have mycorrhizae, both ecto and endo. BAM is commonly used. But the problem with the biofertilizers is that the quality is always a concern. And that is one of the important reasons why this has not been adopted. Otherwise, if we see that in theory or on paper, if we see that these are one of the best alternatives to the, or we can say part of it can be managed by biofertilizer, but still farmers are not, in spite of it being low cost. So poor quality of inoculant is one major reason. And many times we see that the biofertilizer are prepared elsewhere and used at a different location. Now, native population does not actually will accept the microbes from a different source. So although native population is not doing much, for example, if we talk about Rhizobia and we are nodulation is forming in legumes, native population, there is always some amount of it, but it is not very effective. That's why we need biofertilizer. So, but native population will have a better resistance to the environment of that condition as compared to the biofertilizers that we are importing from elsewhere. Apart from that, there are different deficiencies that are there that are not promoting this. So it's a good solution, but there are a lot of flaws in how we are actually utilizing it. So one important thing here is that organic fertility, organic farm is not a matter of input substitution. We cannot directly take up the amount what was recommended in our package of practice and convert it on N basis and we cannot do that because we are not feeding the crop, we are feeding the soil here. Then to conclude my presentation, I would say that to achieve sustainable crop and livestock production, the primary requirement is the maintenance of soil fertility and soil health. Organic practices have both direct and indirect effect on soil properties. Fortunately, the soil health and climate change mitigation are intrinsically linked in a positive manner through soil carbon. Organic farming is a potential system for maintaining good soil health, which in turn is prerequisite for human health and animal population as well. Of course, this is my last slide and some things that we need to talk about also. So some of the recent studies indicate that organic farming can adversely affect climate change, especially if we are not very well in managing our manures, both organic and green manures. So that has to be, for example, I was saying that we have to immediately go for transplanting when we are talking about green manuring. That will help us in retaining more and in the soil, and otherwise it will be lost. Then there can be higher emissions from organic paddy cultivation. This is also very important. Some studies have shown that there are higher emissions. Then organic meat production is at par with conventional meat. So the studies have shown that conventional meat production and organic meat production are, the emissions are almost same. So, but we as an agriculture, and if we're not talking about meat production and all, and then we have to see some of these issues for organic paddy cultivation and the adverse impact of organic farming on climate change. But these studies are very limited as compared to the studies that have a positive result on our environment. But still, as a scientific practitioner, we have to see that these things are not overlooked. So thank you very much.
Thank you, sir. Thank you very much, sir, for a detailed discussion about the organic farming and soil health, how organic farming is useful for the healthy soil and a healthy environment. Now, I request the participant, if they have any query or question, they can may ask. So, first unmute themselves, then ask the question if anybody want any query. Anybody? Okay, I think no one have any query. So once again, sir, thank you very much, sir.
Thank you, Dr. Rai. Thank you so much for giving me the opportunity, and thanks to NRCM for organizing this very important training for students as well as scientific officers. And one thing I would like to add, there's an option in Zoom where you can mute everyone, and they cannot unmute on their own until unless you want them to unmute. So please use this option. There was a lot of disturbance. और एक flow बना होता है ना, तो flow टूट जाता है, उससे क्या होता है?
And one more thing, I just wish to inform you, sir, that is very overwhelming response from the participants. More than 250 registrations in this training program. Presently, there is only 118 are online, but registered participants are more than 250, sir.
Yes, it's a great achievement on part of an ANRCM. We are all part of it, and we're seeing that our society is doing well. It's not just organizing conferences, it's talking about other issues as well and training the students. This is an overwhelming response, and we hope that in future we'll also have more such trainings. I'm really thankful for the opportunity. Thank you.
Thanks a lot, sir. Thanks a lot. Now, we move to another lecture. So now we will discuss about the biological quality and properties. Now we will discuss about the. Hello, I request you all to kindly mute themselves so that there will be no hindrance in the presentation and talking and discussion. So now I request Dr. Sanjay Swami. He will talk about the advances in soil physical and chemical quality management. How we can manage the soil physical and chemical quality. For that, I would like to invite Dr. Sanjay Swami. He is the professor, Department of Soil Science and Agriculture Chemistry in Central Agriculture University, Barapani. Dr. Swami did the PhD from CCHAU Hisar. After that, he worked in Central Soil Sanitary Research Institute, Karnal, associated with the project. And after he joined as assistant professor in Sher-e-Kashmir Agriculture University, Jammu. and he took the position of senior scientist and head of Krishi Vigyan Kendra Punch in Jispos, Jammu. And now he is the principal scientist and professor at Central Agriculture University, Barapani. He is associated with many international and national organizations and more than 70 research papers in his credit. Now I request Dr. Swami. Now I request Dr. Swami. So once again, I request you all the participants kindly mute themselves.
Sir, you are the host, you can mute them also. So that was also creating problem during Vikas presentation, sir. Also.
Mute all. So now I request Dr. Swami.
Okay, thank you, Dr. Rai, for inviting me to present or interact with the advances in physical and chemical qualities of soil. So first of all, I welcome all the participants on this second day of this important training program. And yesterday I have attended this inaugural session. Dr. Patra has highlighted the importance of soil health, how soil is important for us. And just now, few minutes back, I joined today. Dr. Vikas Sharma has also interacted with you people. He has highlighted various aspects of organic farming. And that lecture was very informative. So it is very difficult for me to justify myself after hearing the very nice and informative lecture of Dr. Sharma, because he was quite senior when I was working in Jammu also. So again, I welcome all the participants and I thank the organizing team for inviting me on this occasion. I thank especially Dr. Sanjay Roda, Secretary of the ANRCM, Dr. Atul K. Singh, President of ANRCM, and the organizing team from Jammu, Dr. P. K. Rai, Dr. Arya, for just contacting me and inviting me for this session. So let us start with our business, and let me first share the screen. Slides. Okay, I think slides are visible to you people. You can listen me?
Yes, yes, Doctor.
Okay, okay. So the topic assigned to me is this, just to interact with the theme of the soil physical and chemical quality management. Friends, let us start with the soil health. And I think many speakers has already discussed about soil health. Just to give an idea that soil health is nothing, but it is the change in quality over time. Okay, so we are using soil. There are many natural events. That is only the quality. And if we see in long term, then it is the soil health. And of course, Dr. Kohli has discussed that soil health is being used as a layman language when we are interacting with the farmers. But in scientific terms, we are using the soil quality, because soil health is a qualitative term. With soil, we can feel the soil health, and when we see the soil, even we can judge whether the soil is sound in health or it is not in proper health. So there are some descriptive terms for good soil health. Then if the organic matter is quite high, our soil color will be almost blackish or dark brown, we can say that yes, our soils is good. Likewise, if the crop appearance is very healthy, green, then we can say the soils is healthy. Likewise, this erosion is minimum. Earthworm should be in plenty of number. Infiltration should be very fast. There should be no ponding. Compaction should be very minimum. So if we see these type of, you can say the conditions, so we can say that our soils is in good health. Then coming to the soil quality. Soil quality, friends, it is just, you can say, the guide us for managing the soil for right now and for future times. Because soil quality is linked with the sustainability. That how we are managing the soils, whether it is sustainable in long term or not. So that soil quality reflects. That means if we are assessing the soil, then we can plan the soil in a better way. Okay. If we can assess the quality, we can plan the soil in a better way, that how we should use our soils, that it can serve all the ecological function, all the soil ecological or this functions in a better way. Then again, we can say that soil quality is how well soil does what we want to do from it. There are many purposes of soil, and every person may, so see, engineer will see on a different perspective, a nutrition person will see from a different perspective, a farmer see from a different perspective. So what actually we want, whether all those ecological functions, all those functions for the welfare of the society is being fulfilled or not. Okay, so that is the reflection of soil quality. And therefore the soil quality has been defined as the capacity of a specific kind of soil to function maybe within natural or managed ecosystem boundaries, to sustain plant and animal productivity, maintain or enhance water and air quality, and support human health and habitations. Now coming to the soil, again soil had two type of qualities. One is inherent soil qualities and second one is dynamic soil qualities. Friends, this inherent soil quality it is the natural ability of soil to function. We can't change it easily. Just I have put two examples here, like the sandy soils drain faster than clay soil. It is the inherent quality of soil. Okay. Likewise, the deep soils has more room for roots than the shallow soils. It is also the inherent soil quality. We can't change it easily. Then the second type of quality is dynamic quality. And these qualities depends on how we are managing the soil, how we are using the soil. Like this amount of organic matter present, soil structure, soil depth, water and nutrient holding capacities. So all these are the dynamic soil qualities and depends on the management practices. See, if we are not using organic material, definitely the organic matter or organic carbon content will be less, and that is a very big concern. Just now Dr. Sharma is discussing that on an average in Indian soils we have only 1% carbon or below that. So we have to increase that. That means these dynamic quality we can manage easily and are dependent on the factors that how we are right now using the soils. What are the management practices we are adopting? So the soils, they respond differently when we are managing these qualities. Then yes, why we need the assessment of soil qualities? Just now I have discussed that there are so many ecological services, ecological functions of soil. And if all of its functions is being fulfilled, the soil is performing all of its functions, that we want to check. So see, there are so many functions, and if one or two functions are fulfilled, say crop yield, we are getting good crop yield, that does not mean that our soil has the good quality. Likewise, if we have the good soil water content, good water quality, so that is also not indicating whether our soil quality is good or not. Or in other words, we can say that it is not the single outcome, it is not the single ecological function that can indicate whether the soil quality is good or not. So our assessment is whether all the soil functions that are being fulfilled by the particular soil or not. And for that purpose, we assess the soil quality. Now see how we can measure the soil quality. We can't measure directly. There are so many indicators. There are indicators. We can measure only the indicators. Okay, so these indicators, they are the measurable properties of soils, or maybe plants that can provide some clues about how well the soil is functioning, how soil can function. And these indicators are chemical, physical, and biological characteristic of soil, or we can call as physical indicators, chemical indicators, or biological indicators. Right? We can also call that physical quality of soil, chemical quality of soil, and biological quality of soils. Now see, there are so many physical qualities, so many chemical qualities, so many biological qualities, and I think that all of you know about these, because right from BSc you are learning all those things. In physical properties or physical qualities, we have this aggregation, then soil texture, surface sealing, compaction, porosity, water movement, and water availability. Likewise, in chemical properties, we have the soil reaction, then electrical conductivity or the concentration of soluble salts, concentration of sodium, then nutrient holding capacity, nutrient availability, different type of nutrients we have. In biological properties, we have this microflora, microfauna, microrganisms, roots, then biological activities, organic matter, all these are the biological qualities. So I have just shown one picture here. There are 3 circles. Okay, one circle is of having physical qualities, second one is chemical qualities, and third one is biological quality. But see, these qualities are interrelated. Practically in field conditions, it is not like this, that physical qualities are separated, the chemical qualities are separate, and biological qualities, they are interrelated. And we call that as physico-chemical properties, biophysical, or something like this. So the circle, the portion of this intersection where all these 3 circles are meeting, and only the small portion, this portion where all these 3 qualities are available, that we call as a good soil health. That means there should be a balance of physical, chemical, and biological properties. Then our soil health will be good. Right? If we have good soil physical properties, physical qualities, no, our soil health is not good. If we have only chemical qualities which are good, again, we can't say that our soils are good. That means if we have all these physical, chemical, and biological properties in balanced form, then our soil health is good. And the universal indicator for soil health is soil organic carbon. Okay. Again, this the same issue I am discussing here. Just now, Dr. Vikas Sharma has discussed that we have to maintain soil organic carbon in our soils, because this is the single factor which is properties, whether it may be physical, chemical, or biological health. Then yes, if you see the soil as a crop production function, if we have healthy soils, then that can provide all the essential nutrients in a balanced form, or we can say that we can full crop production. This is from our point of view, from agriculture point of view, that if soils can supply the nutrient which are required by the crops in a synchronized manner, with which can match the crop demand, then only we will have the good crops, nutritious crops, and definitely the higher production. Now, just now I have discussed that the soils have many ecological services, ecological functions, and those functions can be just seen in different indicators. We can just assess these ecological functions by different indicators and see, if we see that how much biomass production we can get from soils. There are so many indicators like yield. We can assess from the yield. Likewise, nitrogen mineralization, then nutrient contents, nitrogen, phosphorus, calcium, magnesium, sulfur, and all other micronutrients also. Then soil reaction, EC, CEC, water holding capacity, all those influence the biomass production. That means these are the indicators for one soil function, biomass production. Likewise, the second function, second ecological service, biodiversity conservation. Again, there are so many indicators like number and biomass of earthworms and other micro and micro flora and fauna. Then microbial biomass carbon and microbial biomass nitrogen. Then soil respiration. These are the indicators which indicates whether this soil is performing better for our biodiversity conservation or not. Likewise, this pest and disease control. Again, we can assess the disease incidence and plant bioassay. These are the two best indicators for plant and disease control. Likewise, this water quality and supply function that can be measured with the help of water infiltration, water holding capacity, hydraulic conductivity, and by measuring these parameters, we can learn about the services of water quality and supply. Likewise, erosion control, we can measure the bulk density, penetration resistance, soil structure, consistency, slacking test, soil loss, water stable aggregates. All these parameters indicate about the erosion control services. That the climate regulation. Again, here the most important function is the total organic carbon. Now see friends, we have the very acute problem of this land degradation. Our soils are being degraded at a faster rate. Earlier, if we see our ancestors, they are, you can say by default, they are doing this organic farming. They are not using any chemical fertilizer because that are not available at that time. And of course, the production potential was very less. But with the advent of this green revolution, you know that we developed high yielding sort varieties. They are the varieties, the plants, they need more nutrients. And that time the challenge was how we can feed our crops. So the fertilizer industry has come up, and we have different type of chemical fertilizer like nitrogen, phosphorus, potassium, and of course, because if we have to utilize all those nutrients in a right way, that we need a proper moisture content, and then the irrigation industry has also come up. But see, we started exploiting our natural resources, particularly the soil resources. If you see the example of this Haryana, Punjab, the farmers, they forgot the addition of this biomass, addition of organic material. And you know that the fertilizer grain, they are containing only and only nutrient element and some quality of filler material. There is no organic matter. So what happened that because of the avoiding of this organic material addition and completely dependent on this chemical fertilizers, we face the soil degradation problem. And now you can see the soils of Punjab and Haryana. Again, we are rethinking that what to do. And we are advocating for organic farming or this integrated nutrient management. So friends, if you see out of 141 million hectare cultivated area, around 104 million hectare area is degraded in one way or other. And we are producing less than 20% of the potential capacity. Okay, if we have the good soils, we can produce more, 20% more. Now you see, out of this 104 million hectare area, around 73.27 million hectare area suffers from water erosion, and almost 12.23 million hectare from wind erosion. These are the two major factors. And I have just put here one estimate that over 5.3 billion tons of soil is lost annually through the water erosion, and we have a loss of more than 8 million tons of NPK. Now coming to all these physical quality parameters. Why these physical qualities or physical properties are important? Because these physical properties, they influence the behavior towards plant growth. Then again, the physical properties, they are influencing, they are governing the chemical and biological properties of soil. They are important for plant support, root penetration, drainage, aeration, retention of moisture and plant nutrients. That means there are so many functions we are achieving, we are getting from these physical properties, physical qualities. And these properties, they depends upon the size, shape, amount, arrangement of different soil separates, their mineral composition, then organic matter content. This is the most important, and although again the pore space also. Now I have listed the important properties here: soil texture, surface area, soil density, porosity, color, consistency, temperature. All of you people know these parameters, but still, because this is the topic assigned to me, so in brief, again I am discussing here. You know, this soil texture, it is nothing, this relative percentage of by weight of the three soil separates, that sand, silt and clay. There are so many, you can say, the system for classification, system for naming of these soil separates, and here the four major systems I have given, how the diameter and what is the nomenclature. So we are just mostly following this ISSS system, where the clay, silt, fine sand, coarse sand has different size of diameters. Then if we have the percent with us, you can say the soil separates, then we can know the texture of soil with the help of this triangle. And nowadays, a very simple triangle app is also there. Just we have to put the values of this maybe 2 factors, clay or silt, and we are getting the third one. Then coming to structure, it is the simple, you can say, the arrangement of primary soil particles and their aggregates into certain defined pattern, that is soil structure only. And because you know that it influences the soil by increasing the average size of pores. And this structure, it is alterable. We can alter the structure, but not the texture. And there are different type of structures like this platy, prismatic, columnar, blocky, crumbly, all those things you know. I have just shown here that how the permeability by the structure. You can see this first column here, single grain or granular. These are the, you can say, the structureless type of the soil, where we have the high permeability. Then again coming to blocky and prismatic, we have the moderate permeability of water. Then coming to this platy or massive structure of the soil, we have less permeability of water, which is just shown by this figure here. Now again we have the different structural class in the different structure units, and that those classes are very fine, medium, coarse, very coarse, and the values or the units are given here. You can just have a look at this. Then density, you know that specific gravity of soil particles is 2.6 gram per cc, and this is the you can say the particle density. And if there is no pore space, then this particle density will be 2.6 gram per cc. And if we include this pore space, then it will be the bulk density. And bulk density is important because when bulk density increases, the amount of pore space decreases. There is inverse, you can say, the relationship. And here I have shown this relationship that in different type of soils, how it is affecting. See, in sandy soils, we have the less high this bulk density and less pore space. In loamy soils, we have the comparatively less bulk density and this more pore space, and likewise silt, loam, and clay soils. And see, if we have the low bulk density, that reflect that we have the loose soils. If we have high bulk density, that indicates that the soil compaction is more. The maximum value of bulk density can be the value of the particle density. Now coming to the pore space, again you see that pore space is the volume or amount of space within a soil that is not occupied by the particles or organic matter. And it also affects the texture, structure, and compaction. Then coming to the soil consistency, you know that it is simply the reflection of stickiness. We have some sticky soils, some very sticky soils, some non-sticky soils. Okay, so the knowledge of this consistency is important, particularly for tillage operations. How with the ease we can carry out tillage operations. And of course, it gives an indication about the soil texture. Then soil color, friends, everyone know there are different type of soils have different colors, and with the help of this Munsell color chart, we can just determine the soil color. And with the help, there are three values: hues, value, and chroma. And I think you have just gone through the BSc parts that how these hue, value, chroma we can determine. Then yes, now how these properties are negatively affected and how these physical degradation or physical quality is negatively affected. See, friends, nearly 89.52 million hectares suffers from physical constraints that may be shallow depth, soil hardening, slow and high permeability, subsurface compacted layer, surface crusting, temporary waterlogging. So all these problems are physical, you can say the quality problem, and 89.52 million hectare area suffers from this. Now, I told you that the soil organic matter, it is the soul of the soil. It is the single most important factor which governs all these physical, chemical, and biological properties. Here, with specific reference to these physical properties, I am discussing here that the soil organic matter, it governs the bulk density, it governs the aggregate stability and moisture retention. In case of chemical properties, all major properties, you can see the nutrient availability, cation exchange capacity, reactions with different type of contaminants, and how it shows the buffer capacity. Everything is governed by the organic matter. Likewise, in biological properties, mineralization, microbial biomass, enzyme activities, all these properties are governed by soil organic matter. So you can say that for improving the physical properties, the single most factor is the soil organic matter, soil organic carbon content. We can improve all these properties of soil organic carbon. Just now, Dr. Sharma has also discussed that earlier we are by default organic. Our ancestors are doing this organic farming. Okay, and the main difference is that after advent of this chemical fertilizers, we started feeding only plant, because chemical fertilizers, they have only the nutrient element, and those fertilizers are placed near the root zone. In the root zone, from there the plant can take up all these nutrient element and rest of this may be lost. But the philosophy of organic farming is to feed the soil, not to feed the plant. And there are various options like this crop residue, manures, green manures, mulching, compost, and natural fertilizers like this, rock phosphate, lime, all those things, so we can use. And when we are doing this, the organic carbon content, the organic material, when we are adding organic carbon content was very good. But we have exploited the soil resources and the consequences we are facing right. So Dr. Sharma has already discussed various options, friends. The important one is crop residue management, because crop residue also affect all these chemical, physical, and biological properties, and it prevents land degradation. Now you can see the potential that throughout the world we are producing 3.10 billion megagram of this crop from cereal, 8% from legumes, 3% from oilseed crops, 10% from sugar crops, and 5% from tuber crops. If you see the Indian scenario, we are producing annually around 700 million tons of crop residue, and out of this 700 million tons, 187.48, or roughly you can say 200 million ton is available for incorporation, and that 200 million ton can provide almost 8 million ton of NPK. You can just imagine that if we are not using this crop residue in proper way, that how much quantity of NPK we are losing. Then coming to our part, this Northeast India, you know that this Meghalaya is the wettest place throughout the globe. We have the highest rainfall throughout the globe, and we are blessed with the greenery. We are having different type of crop. We have different type of weed that can be even not controlled easily. So you can have a look just here that we are also producing the main rice, maize, pulse, soil seed. Almost 5 to 20 ton per hectare. And I have just listed here the important weed species and their nutrient content. That means if we are recycling this weed biomass into the soil, we are enriching with the nutrients, and of course we are adding the organic material, which is the soul of soil. Otherwise, just now after harvest of paddy, farmers, they are in hurry to sow the wheat crop, and that's why they take these measures. Simply they burn the crop residue, but it is not the right practice, and many awareness programs are being taken up, particularly in the Punjab, Haryana, and Western UP, J&K, all those areas. Friends, otherwise we can use this crop residue even as mulch also. Okay, and if we are using as mulch, then we are getting multiple benefits because of this moisture conservation. By mulching, we can just conserve the moisture. We can lower the erosion. We can reduce the greenhouse gas emission. We can moderate the temperature, and with all those effects, we will have better aggregation, better hydraulic conductivity, high quality of organic matter, and better soil carbon pool, better root proliferation, and nutrient recyclings. These are the, you can say, the beneficial effects which we can get by mulching of this crop residue. Then another options we have that we can utilize all this crop residue or any type of organic material for conversion the biochar. Biochar, I think yesterday Dr. Mehdi has taken a full session. But again, here I want to discuss, because this is very important from the point of view of increasing the carbon content in soil. Hence, it is nothing. Earlier, see, we are preparing the charcoal. Okay, it is the same like thing. Okay, only here we are having the high temperature and no oxic conditions, and this process we just call as slow pyrolysis. Okay, it is very, you can say, the very innovative thing and very economic for the farmers. Very easy technique. They can just prepare biochar at their field also. And when we are just putting these biochar biomass and converting into the biochar, almost 50% of the carbon we are just preserving, we are just storing again in the soil. And this biochar is having the stable carbon. That means it can be stored for a quite long time. And this is, you can say, the simple process that it is a diagram which shows that how these things are functioning. I am not going in detail because the methodology in a simple way I am explaining in the next slides. Yes, basically FIDA had developed a very farmer-friendly kiln for preparation of this biochar. And the first figure, you can see that in the upper part we have a one lead which is opened here, and in bottom part we have different hole, or you can say the perforated lower surface. Okay, you see this figure number 3 here. We have to create a central vent that can be created by inserting a any type of pole. Okay, in second figure you can see that first we have inserted this pole, and we have filled all this this biomass, whatever we have with us. And after creating this central vent, we have to put this assembly on some big type of stone. Okay, then we have to ignite it from bottom side, and upper lid we have to close. Then you see when the blue exhaust will start coming, that will happen only around 450 to 500 degrees centigrade temperature. We can just close the top vent and again shift the assembly on the ground. Then we can just close this lower portion also. We can seal all these upper and lower part. And after completing of this product, we can just have the biochar. Friends, there is even automatic system also in the our location in ICR Research Complex. We have a automatic biochar production unit, and here we can feed around 300 to 400 kilogram biomass in an hour, and we can have this biochar within 15 minutes. And these figures, you can see that here we have this full of drums with the biomass material, any type of biomass you can use. And this is the unit, and it is being filled, it is being fed, and after this initiation of this process, immediately after 15 minutes we can get the biochar. Then second thing is this application of farmyard. Friends, this is the very old technique, and in the even I have seen in the Punch also, even in Northeast also, farmers they are using it. But the main thing is that we have to use it in a right way. We have to adopt the proper technique. Many farmers just you can say put the FIM in hip, and then they are keeping it for a long time. But this is not a good practice. After just putting this FIM, we have to spread it uniformly and mix it in the upper soil level so that we can get the maximum benefit. We don't have any type of nitrogen loss. Then, of course, vermicomposting, Dr. Sharma has discussed. It is a quite promising technique, very easy, very farmer friendly, very cheap, and we can add good organic carbon in our soils with the help of this also. And apart from this organic carbon, it is a good source of nutrients also. Comparatively, it has higher NPK content and even micronutrients. If we compare with FIM, and because of the action of worms, we have some hormones that are also, you can say, the beneficial for the particularly the fruit crops. Then the biogas slurry, I think that it was the government initiative that in the rural areas this scheme was implemented, and many households they have this biogas slurry plant, biogas plant, and this wastage after producing the biogas, what the remains is there, that is also have a good organic carbon content as well as the nutrient content. Then different type of oil cakes, friends. There are two types. We have the edible oil cake, non-edible oil cake, but both type of these oil cakes
Dr. Saab, I think there is some network problem. You are not audible, even slides are not moving. Dr. Swami. Hello, Dr. Swami. I think there is a problem in network. Dr. Swami. He's joining again. There is some technical issue, a network problem, because he's delivering the lecture from northeast, that is Barapani. So there is some problem. Now again he is trying to join. Okay, अभी किया मैंने. Dr. Swami, please unmute. Dr. Swami. डॉक्टर साहब अनम्यूट करो आप. अच्छा, एक मिनट डॉक्टर साहब, एक मिनट डॉक्टर साहब. करो डॉक्टर साहब. हो गया?
Okay, हो गया. Okay, friends. So here I have shown some just green manuring practice which we are doing in our area, and this is the, you can say, the stem nodules also from this Suspesia rostra. Friends, just I want to tell about this innovative practice, that we can induce the nodulation in Suspesia rostra also. Okay, we can just you can say the mandatorily we can regulate this nodulation, and the practice just I have discussed here, that we have to sow the Suspenia seed by first June. Then the nodule extract of Azorhizobium we can spray on the emerging seedlings, and with the help of this spray, the nodulation will occur after 15 days of inoculation, and we can have this crop up to 30 days and then can incorporate in the field. So this is induced nodulation. This is not natural. We can induce the nodulation process. And here you can see the artificial nodulation. The first figure is showing, first picture is showing. And the second one here, just I have shown the comparison. First, this stick is showing how this less nodulation is there. But in the second stick, you can see how much nodulation is there with the induction of this, you can say, this extract. Then there are so many practice of addition of this organic material. There are different type of agroforestry system. In our area, we have the alder-based farming system. This alder is very good plant. Just like in Rajasthan, we have the khezdi. Here we have this alder plant. It is you can say nitrogen fixing plant also, and very good biomass is being generated. This biomass that is incorporated into the soil. And here just I have shown how much liter, dry liter per kilogram of tree we are getting. So, see, if we have the 16 number of plants, we are getting 56.3 kilogram per tree. So this is just how much nitrogen we can add and how much litter yield we are getting from this elder population. Again, here I have shown that how much this soil organic carbon we can have, we can increase with the help of different type of agroforestry system, and the agroforestry with the elder based farming and hedge based agroforestry farming, these are this promising. Then coming to the chemical properties, friends, you know that all these properties like this pH, EC, CEC, organic carbon, then available nutrients, these comes under the chemical qualities. And I am not going to much depth because regarding this chemical qualities, all of you know. So this is about soil pH, how soil pH is affecting different type of soil properties. Then again, this electrical conductivity. If we have the EC more than 4, then the soils, they are classified under these saline soils. Likewise, the CEC, because just Dr. Rai has requested me to finish well in time. So I am just skipping many things here. This is the relationship with soil texture and soil this cation exchange capacity. This organic carbon we are discussing since, right? And of course the available nutrients, right? This N, P, K. I have given here the range. How much means the critical limits are there? By which chemical methods we can assess all those available nutrients. Likewise, the secondary nutrients, then micronutrients. Then, of course, some antagonism or some synergism about this different nutrients, how one nutrient can just benefit the absorption of others. Those things you know better. Then, friends, we have to analyze all these properties. For these soil quality parameters, we have to analyze physical properties, we have to analyze soil chemical properties, and for this we have the proper soil sampling collection method. That methods you all people know. Okay, so now when we have all these parameters with us, physical parameters, chemical parameters, then we can assess the soil physico-chemical qualities of a particular soil. For this, first we have to do the principal component analysis, and here we have to give we have to take some reference soil also. That may be natural system, maybe forest, or maybe some nearby areas which are not particularly in that particular management system. Okay, so we have to assign this reference soil as a 100% marking, and then we have to give the marking to the other parameters which we are measuring. So by this, I have given one formula here. By putting all those values, we can just have the soil physico-chemical qualities. And after getting these qualities, we can just have the qualification of this index, whether the soil quality index which we have measured for a particular soil is better, good, moderate, low, or very low. That we have different type of values here. No? If the value is from 0.8 to 1, that is the class 1, and we have very good, better quality. Then 0.6 to 0.79, good quality. 0.35 to 59, it is moderate. 0.2 to 0.34, it is low. And if it is 0 to 0.19, this is the last class, and it is the quality is very low. Then again, friends, just now I have discussed the chemical properties. Again, I have to just highlight that around 17.36 million hectare arable land is affected by chemical degradation. That may be soil acidity problem, maybe salt affected soil, saline soil, alkali soil, like this. And you know that acidic soils, these are characterized by low pH, and we have the deficiency of phosphorus, potassium, calcium, magnesium, vitamin, boron, particularly in the northeast region. Approximately all soils, 95% soil are acidically, and out of this, 65% soils are highly acidic. Likewise, we have the saline soil, saline sodic soil, and sodic soils. The quality parameters here I have given. You can just assess with these quality that whether the soil is of saline, of sodic, or saline sodic soils. So friends, we are facing the 10 major soil threats which are proposed by the FAO. And I have just shown this figure. You can read it out that what are the major 10 emerging soil threats. And coming to the management options regarding here I have put all those mixed, whether maybe the physical quality or maybe the chemical quality. So the scientific land use planning is the important factor. Then we have to assess soil fertility and monitor it on GIS basis. Then soil test based the size specific balanced and integrated nutrient management, use of organics, crop rotation with legumes, organic farming, soil carbon sequestration, conservation agriculture, soil water conservation, then reclamation or management of problematic soil. These are the very important, you can say, the options for managing all those type of soils. So here just I have shown that at a country level we have prepared different type of nets, soil maps. First map is the soils of India, how means different type of soils are spread throughout the country. Then second one is soil degradation map, which shows in which part of the country we have the degradation problem. Then the states of this state level, then district level, and then local level. If we have this type of accurate information, we can plan our soil in a better way. Then integrated nutrient management, we have different type of options, and many speakers, they have already discussed. Dr. Sharma just now have discussed that how we can use this organic option or integrated way of nutrient management. And friends, this portable, this mini lab, it is very, you can say, the very good and very innovative idea. And this is, you can say, the portable kit by which we can have almost all the parameters assessed, which particularly farmers need. And the main use of this is that we are just collecting the samples, we are assessing at district level in different KVKs, and we are preparing soil health card and providing to the farmers. That means we are just giving the soil fertility or soil health status at the doorstep of the farmers. And by adopting these, by knowing these health status, they can improve. Then coming to the this nano zinc treatment. Then with conservation agriculture, I think all of you people know about the practices of conservation agriculture, how these are beneficial for particularly then this amelioration of acidic soils. We have to bring all the problematic soils under cultivation so that we can have the good or higher production to feed the growing populations. The biochar is a promising option. Earlier, we are using this lime also for this amelioration of acidic soils. Then we have to use the salt affected soils also. There are different type of practices, different type of tolerant varieties also. Then there are so many technology, engineering or bioengineering technologies that can conserve the soil and water, like contour bunding, contour conservation, bench terracing, staggered fencing, vegetative barriers, sack dams. All those can reduce the soil erosion, like things. Then there are so many soil health related government initiative also. Only the few I have listed, that integrated watershed management program, then National Mission for Sustainable Agriculture, National Mission on Soil Health Card, Parampragat Kasi Vikas Yojana, National Biogas and Manure Management Program, Nutrient-Based Subsidy. All these schemes are promoted and implemented by central government just to ensure the good soil health. And friends, at the end, I just want to say that because we all are dependent on the soil, we derive directly or indirectly our nutrition, our food from the soils. That means the soil is the mother of all creatures on this planet, and that's why the theme for the this 2022 Soil Day is to conserve the soil from our food begins. And in conclusion, just I want to say that if we have the good physical and chemical and biological quality, we can assure this good soil health. If we will have these healthy soils, then we'll have healthy crops, higher production. If we will have healthy crops, then we can give healthy and nutritive foods, and we'll have healthy life. So this is in a nutshell my conclusion, that we have to manage soil physical, chemical, and of course the biological qualities of soil. So thank you very much.
Thank you, Dr. Swami. You have rightly said that save the soil, save the mankind, and save our planet. So you have already discussed them in detail about how we can improve the physical and chemical quality of our soil through all the aspects. So once again, thank you very much, sir.
Oh, thank you, Dr. Rai. If any queries or any question is there, I am here to address.
If anybody want to ask anything, they unmute themselves and ask the question. If not,
I think no one is asking anything.
okay.
And okay, then again, thank you, Dr. Rai, for giving me the opportunity. And again, thanks to the whole Academy of Natural Resource Conservation and Management team for providing me this opportunity. No problem. If any participant have any query, I have given my email also. I have given my contact number also.
Doctor, they are mentioning in the chat box that it is very informative session and lecture. So
okay, thank you. Okay, thank you, Dr. Rai.
Okay, thank you, Dr. Swami. Thank you. Now, without wasting the time, I am just requesting Dr. H.K. Rai. He is the Professor, Department of Soil Science in JNKV, Jabalpur, and he will talk about the soil resource conservation. And Dr. Rai did his master and PhD from Govind Ballabh Pant University of Agriculture and Technology, Pantnagar, and PDF from Pantnagar also. He was affiliated with the NRM scientist as an NRM scientist in CIMMYT, India, and he joined as assistant professor in Scotch Kashmir, Srinagar in Kargil remote area, in hill area. And after that, he joined Jawaharlal Nehru Krishi Vishwavidyalaya, Jabalpur as an associate professor. Now he is professor. He guided 28 students, 22 MSc and 6 PhD students. He has handled 8 research projects, and now presenting he is handling 2, total 10 projects. And he was also the visiting scientist in Brazil and Vietnam. He had got 4 awards, national awards, and he had made 83 publications, research papers, 2 books, and 16 book chapters. So, keeping in view the vast experience and working in hilly areas and plain areas, I request Dr. H.K. Rai to please talk about the soil resource conservation. Dr. H.K. Rai, please. Dr. H.K. Rai. Okay. Yes, Dr. Rai, your slide is. Please unmute yourself.
I think I am audible.
Yeah, you are audible. Just
And
give it in a
screen
slide
is
mode.
visible.
Give the presentation in slide mode.
Now it's visible, I think.
Yeah, it is visible, but put it in a slide mode.
No, actually, I have opened a slide already. I have opened. Is
Yes,
it visible or not?
You have opened, but get it in the slide mode so that give.
Okay, I should put it in slide mode like this. Yeah. Okay. Thank you, Dr. P.K. Rai sir. I was listening, Dr. Swami. He has explained so much. So here, actually, I am around 1 hour 30 minutes late. So we'll discuss about conservation agriculture for soil health sustainability. Before going to conservation agriculture, we should know what is soil health and what is sustainability. As Dr. Swami explained, soil health is decided by or regulated by 3 key properties: physical, chemical, and biological. He also explained some physical property like texture, structure, bulk density, release behavior, compaction, like that. In chemical properties, he explained pH, electrical conductivity, organic carbon, cation exchange capacity. In biological property, he explained the microbial biomass, carbon, microbial activity, microbial population. So in totality, the soil health is governed by these 3 key soil properties. And in another slide, he explained these all properties directly linked to soil organic matter or soil organic carbon. So what I could understand, or what I want to communicate, the key property of soil is associated with soil carbon. And it is unfortunate, with introduction of chemical fertilizers, our soils getting deteriorated, which can be understand from the data, which said that at initial stage of green revolution, 1 kg NPK produces around 13.8 kg grain, which reduced to 3.4 kg nowadays. So means huge efficiency of nutrients are going depleted. And in my opinion, the key cause behind this is deterioration or depletion of soil carbon. So with this viewpoint, we'll move ahead how this conservation agriculture can sustain soil health. As you know, conservation agriculture is stand on 3 key pillars. 1, not to disturb soil. 2nd, to cover the surface with crop residue. And 3rd, to rotate the cropping system or diversify the cropping system. I will explain each component of this CA in relation to soil health. As I have told, the buildup of carbon or carbon sequestration in soil is key for sustaining soil health. Number of studies conducted at Pantnagar, PIU Ludhiana, and Jabalpur revealed that if you are incorporating the crop residue, the rate of buildup is very poor, because for incorporating the residue, one have to till the soil or open the soil, and degraded or that decomposed carbon material get oxidized during that tillage practice. So one hand you are adding the residue, and second hand you are depleting the organic decomposed organic carbon through oxidation. So build-up rate through incorporation is not up to that mark. You can find a number of study by Vijay Singh from PU Ludhiana, number of long-term fertilizer experiment at Pantnagar, which explain that long-term incorporation of crop residue did not increase carbon sequestration in soil up to that mark. So first activity which need to be followed, that don't till the soil. Second, cover the crop of the soil surface, which not only facilitate the eradication of crop residue burning, but also regulate the soil temperature, soil aeration, improve the biological activity through providing the substrate for microbes. Also reduce the insolation, means direct sunlight, which warm up the soil and cause the accelerated evaporation. So by covering the soil surface with crop residue, provide number of benefits. And third pillar of CA is crop diversification, which not only ensure the return, but also regulate the mining of nutrient from soil at different horizon, and also promote the incorporation of carbon material to the soil through their root system. So these three are key pillars for conservation agriculture. Before moving ahead, I want to share the first CA machine was developed at Pantnagar when I was the student, and which was later on promoted by different ICR and CG system institutes, and which facilitated the farmer to cut their cost of production and improve the soil health. So here are the principles of conservation agriculture: residue mulching, minimum disturbances to soil, cover cropping, and integrated nutrient management, which provide the base for sustaining soil health by promoting the microclimate management, carbon sequestration, improving soil biodiversity, and optimizing the nutrient management. This is the scenario of conservation agriculture. During 1974, the CA coverage across the globe was only 2.8 million hectare, which reached around 155 million hectare in 2012. And on right side, you can see the contribution of different continents, subcontinents in CA. So this shows that most of the CA practice are being followed in South of America, mainly in Brazil, then followed by North America, Australia, Europe, and big part of this Europe and Africa. So here are some potential of CA. It recycles the crop residue without incorporation, promotes carbon sequestration, and arresting the declining of factor productivity, which I was explaining, the decreasing nutrient use efficiency. It minimizes soil erosion and nutrient loss due to covering the soil surface through crop residue. It improves the input use efficiency, particularly natural resources, that is from soil and the water use efficiency. It reduces the water demand by curtailing the evaporation losses. It also checks the non-point pollution. Here I want to say, in general, adoption of CA cut the number of tractor passing for tillage practices, which ultimately reduces the burning of fuel and curtail the GHG emission from agriculture sector and pollution of atmosphere. It improves the biological activity by providing the carbon substrate to microbes. Here we start first component, don't disturb soil or minimum disturbance of soil. Some student ask me, sir, if track passing from field, why it is called no till or zero till. So in this regard, I want to share that it is different than CD. In this CA, we are not tilling the field, we are putting the seed by one pass by cutting the slit under the crop residue condition. So what this minimum soil disturbances result, you can see here on left side it is tillage intensity, on the right side it is surface cover. If the retention of residue on surface is more than 30%, only then it will call CA. Otherwise, 15 to 30% crop residue are retained on the surface, it will be reduced tillage. And if residue in the field is less than 15% and intensive tillage is there, then it will call conventional tillage system. Here are some tillage practices. No tillage, in which we are not preparing the field by tillage practice. We just put the seed by one pass of the seed drill. Then minimum tillage, we just provide one bed preparation practice and then put the seed. Then strip tillage, this concept was given by Dr. Ratan Lal, renowned soil scientist, in which only the tillage is practiced in the strip and for the putting the seed, and the gap between the row crop, we cover the soil surface with crop residue. Then mulch tillage, in this we can put the seed under around 3 ton residue retained on the soil surface, because there are punch planter which you can see here. It put the hole in the soil under the residue, and see the seed and fertilizer can be put down, and there will be no problem of from this loose residue on the soil surface. Then another this RCT technique is there, that is called furrow irrigated raised bed, which not only save the irrigation water, but also provide continuous no-till practice, in which we have to adjust this bed shaper with our seed drill machine, and 2 side tines are there which can put the seed in line, and simultaneously that reshape the this furrow. But this practice is mostly beneficial in light textured soil, like soils of Punjab, Haryana, Western UP, alluvial soils. But it is not very much useful in heavy soils like soils of Jabalpur, where we are having vertisols. And this is again important to remember that this fur practice is very useful for double or triple no-till. Once you prepare the bed, then you have to cultivate at least 3 cycle crop. Here are some glimpses I have taken from my experiment when I was working with CIMIT at Modipuram. I've gone through maize wheat and rice wheat system. Rice and wheat both are shown on the side of the raised bed. However, in case of maize, maize was seeded on the middle of the raised bed. In this system, around 30 to 50% less irrigation time is required as water flow in the furrows. 25 to 30% less irrigation water is required, and it's sustain the productivity or in some cases it enhance the productivity. Here are some effect of minimum no disturbances of soil, no mechanical disturbances of soil. You can see in case of heavy rains, the crusting is the big problem. You can see in case of conventional tillage, the strength of soil crust to which this plumule of this seed should break. It offers seed crust offers the different state of pressure or penetration resistance in megapascal. You can see under no-till system, which is in light color, there is no problem of crusting. However, in conventional tillage, with increasing the number of days after rainfall, the crust strength is increasing. So in this case, emergence of crop is not take place, and you have to break that crust through some mechanical disturbance. Here you can see the buildup of organic carbon. I have shown here two sides, one side having less carbon and other side having high carbon. In site 1, you can see under zero till or no till, the carbon buildup or organic carbon content increase was more as compared to the site where organic carbon content was initially high. But in both the site, organic carbon increase in soil organic carbon was more under CA, under no-till practice. In this case, also one thing is important: the residue retained under soil surface decompose slowly and recharge the profile, and it not require any additional application of nitrogen. However, when you incorporate the crop residue in soil, you have to add 25% more nitrogen over the recommended dose. Otherwise, your crop will see yellowish. Here are again some data from India, which indicates that when you go for conventional till, wheat and rice both, your carbon content is much lower than that when you follow no-till in rice wheat cropping system at different zone or different soil profile. Another impact of CA, you can see in green bar, the number of rhizobium cell enhanced significantly. It is 2-year mean data, which indicates that nodulation property increased, in particularly in leguminous crop or oil seed like soybean as compared to conventional till. So if nodulation property improves, that indicates that carbon, this nitrogen fixation is more, which ultimately goes to the soil for next crop. You can see here the population of earthworms, which now commonly not seen in agricultural field. You can see due to excessive tillage, first bar, that is red bar, you can see the number of earthworm per meter square is very less, even 2.5 earthworm per meter square. However, in conservation agriculture system, that is no-till or zero-till system, you can see it is around 25 earthworm per meter square. So if earthworm is population is increased, it also improve the soil health. This is another set of data from India. Then that was component 1. Least disturbances of soil are opting zero tillage or no tillage. Then second component of CA is retention of crop residue on soil surface. Here I am showing 4 glimpses. One is what in general farmers were practicing. They harvest the rice and wheat and burn the crop residue. Second practice, in second glimpse, this is happy seeder, which can put the seed and fertilizer in around 6 ton, 60 quintal crop residue per hectare. Or if you don't have this happy seeder, you can go for this double disc planter by removing some residue from the field for other purposes, what Dr. Swami was telling, for production of biochar or this energy, and then put the seed using your double disc planter, which can be operated by 25 horsepower tractor or 35 horsepower tractor. However, in operating the double disc, this happy seeder, you have to have at least more than 55 horsepower tractor. You can see in residue after seeding, it is the glimpse of here Jabalpur of visa form. Why we are bothering for this? This is the scenario of residue, crop residue production and unused crop residue on the right side. So in the bottom, I have showed that either you have to burn or use the CA and find the best result. By adopting the CA, you can stop the residue burning and grow your crop with crop residue. And what are the benefits with crop residue? It's about 679.3 million ton of crop residue generate annually, of which about 70% comes from cereal. Dr. Swami also showed that value in the table, and the nutrient potential is about 5.6 million ton from this crop residue. It improves soil health, protect from erosion, and restore soil property. It enhances soil biological health. It improves the efficiency of nitrogen fixer, microbial biodiversity, and activity of by providing food for soil organism. This flora and fauna, it could be micro and meso. Then why farmers prefer residue burning? To catch sowing of, due to climate change, that window of sowing of crop either in particularly in the Rabi season is reduced. So farmers follow the easier way, and to catch the sowing of succeeding crop, they burn the residue. Then after burning the residue, they require less tractorization, reduce the labor cost, reduce the weed population, and in some places residue are removed from the field for feeding the cattle, and this is also preferred residue burning because the decomposition is a time-consuming process. But what they lose after burning, 80, 25, 50, and 20% of nitrogen, phosphorus, sulfur, and potassium are being lost during burning. 70% of carbon dioxide, 7% of carbon monoxide, and 0.66% of methane and 2.1% of nitrous oxide are escape from the field due to crop burning. So if we have to sustain soil health, improve the nutrient status, we have to stop the crop residue burning. Because the crop residue act as manure or nutrient source. Decomposed crop residue improves available nutrients by enriching the soil. It can bridge the gap of demand and between demand and supply of chemical fertilizer. So by this way, we can say grains for people and residue for soil. You have to take, because in last slide, Dr. Swami quoted that soil is mother. So if you are getting something from mother, what you are not of your use, you have to return to that mother so that mother can feed you for longer time under sustainable manner. Here you can see some facts. Crop residue versus carbon sequestration in soil. In India, around 664 million ton per year. It is reported by Dr. Ratan Lal in 2017. Contribution of cereal is around 332 to 433 million ton per year. It contains 40% carbon. So according to the data, around 266 million ton carbon can be sequestered every year. If 50% of this carbon is recycled, 133 million ton carbon per year and 13.3 million ton carbon per year sequestered in soil with 10%, by assuming 10% humidification efficiency. So by this way, you can sequester the carbon and clean your environment by curtailing the crop residue burning. Then societal value of we are thinking, or this government is thinking for putting carbon credit scheme in India. So in that way, around 122 US dollar, it is per ton carbon is credited. So monetary value of carbon sequestration per year is around 1.6 billion US dollar per year if we can sequester instead of burning. So here are some facts, what we are burning, what that residue can provide to the soil or recycle to the soil. So here are some nutrient content. Major nutrient contents are here in different kind of crop residue, which generally farmers burned in the field. By retaining the residue on the surface in long term, the bulk density of soil decreased. If bulk density of soil decrease, you have already listened from Dr. Swami that if bulk density is less, means less compaction is there. So energy lost for penetration of root required for by the crop is less, so your productivity will enhance definitely. Here are some more facts from 6-year mean value. If you are opting this CA in your rice wheat mung bean system or rice wheat system, here are some benefits in terms of productivity, irrigation, water, energy requirement, and net returns. This again data from Karnal. Then reduction in soil erosion. If you are increasing the residue retention on the soil surface, as the retention of amount of residue or covering of soil surface increases, the reduction in soil erosion also increases. So more reduction, soil erosion was reduced due to retention of or covering of soil surface through crop residue. Here are some data. Another parameter with this physical hydrophysical parameter of soil, which associated with soil health, the infiltration rate. If you are retaining crop residue on the soil surface, you can see your infiltration rate increased significantly, which ultimately recharge your profile of the soil profile of your field. Here are in maize mustard cropping system, the effect of this minimum tillage or no tillage and crop residue recycling under CA on carbon, increase in carbon content and microbial biomass carbon. You can see it is in this microbial biomass carbon and carbon content in soil increase significantly in CA as compared to your conventional cultivation system. This is again data from India. So third component of CA is crop diversification, which ensures the return from the field. Here, this is a glimpse from Jabalpur itself. We are putting soybean with pigeon pea, soybean with jowar, maize, then sunflower in different ratio, and it provide the best return from the cultivation. Here you can see by diversifying the cropping system, the carbon content increased under no-till as compared to conventional till system. Here are some biological property which improves through adoption of conservation agriculture, dehydrogenase activity, alkali phosphatase, soil respiration, and microbial biomass carbon. You can see these biological parameters improves under CA as compared to conventional system. So because you are already very late, so I'm not taking much time. I will provide the time for discussion. So in totality, continuous retention of crop residue on soil surface coupled with no-till is key component of CA. It's improved soil health by providing better carbon sequestration, improves aggregate water stable aggregates, reduce the bulk density, improve the water retention and transmission behavior of soil. It also improves the moisture conservation. It regulates the temperature, particularly in Rabi season where temperature is very low, and effect of terminal heat during maturity of wheat crop, and also improve the weed control. One thing I want to share here, after adoption of the CA, you will face the problem of weed initially during 3 years. After 3 years, once surface beet seeds were exhausted, then you will find least problem of weeds. CA promotes carbon sequestration. It improves input use efficiency, provide carbon facilitate carbon diversification, curtail the GHG emission, and also reduces the fallowing. In high rainfall zones, when you go for seeding of Rabi crop, you have to wait for longer duration for getting optimal tilt of soil for tillage. So if you are following the CA, you need not to wait for this optimal moisture for tilt. It also a very cost-effective technology, but we have to remember the CA is a machine and management driven eco-friendly agriculture system. So thank you very much, and Dr. Rai, for providing me this opportunity. I welcome the questions. If some
Thank you.
questions are here.
Thank you, Dr. Rai. You have discussed in detail about the conservation agriculture and what is the importance of conservation agriculture to build the soil health and minimize the environmental pollution. So now this session is open for the discussion, and I request the participant, if anybody have any query and question, they may ask. First, they unmute themselves and then ask question. Either they put their question in the chat box also. So anybody?
Good afternoon, sir.
Good afternoon.
Sir, I have one question.
Yeah.
Sir, for farmers, which is convenient, incorporation of residues or by retaining it?
Actually, what I was sharing, we have to careful about the convenience of soil. As I have told, Dr. Yadvin Singh, number of means, I think 10-year continuous study of Dr. Vijay Singh and Yadvin Singh at PU Ludhiana revealed that, I have that report, the potential of carbon sequestration or buildup of organic carbon in soil under residue incorporation system is poor, because when you are tilling the soil for incorporating the residue, at the same time you are exposing the soil for oxidation of decomposed carbon material. So in retention is better than incorporation in terms of soil health, because it not require addition of additional nitrogen. If you are incorporating the residue, crop residue, it require additional application of nitrogen to maintain the CN ratio. But in case of CA, putting the residue decomposition start from near the soil surface, and then slowly it get decomposed, and there is no need for application of additional nitrogen in soil.
Thank you, sir. Another question? Any other question? Okay, Dr. Rai, it is a very nice presentation, and you have discussed all the practical aspect, what you have done and what is going on regarding conservation agriculture. So thank you for sparing the time, and thanks.
Thank you, Dr. Rai, and all the participants. Nintu, Dr. Mandal.
Hello, sir. Hello, sir.
How are you?
Fine, sir.
Fine. Great to see you.
How are you, sir?
I'm fine. Okay, thank you. Thank you very much.
Thank you, Dr. Rai. Now we are moving to next discussion. Nowadays we are everywhere we are talking about the nanotechnology. How this nanotechnology is beneficial for our soil health. For that, I am inviting the Dr. Nintu Mandal. He is the assistant professor in Department of Soil Science in Agriculture Chemistry, also in Agriculture Chemistry at BAU Sabad. Dr. Nintu Mandal did his BSc from BCKVV West Bengal and MSc and PhD from Indian Agriculture Research Institute, New Delhi. He got many fellowships: ICR Junior Research Fellowship, ICR Senior Research Fellowship, IRE Merit Scholarship, UGC Junior Scholarship, and DST Inspire Fellowship during PhD tenure. He got many awards, 2 awards from Indian Society of Soil Science, Journal Award and Best Doctoral Thesis Award. Apart from that, he got gold medal for outstanding doctoral research. He has published 26 research papers and review papers in several national and international reputed journals. He has co-authored 9 book chapters and authored 1 textbook, that is Agriculture Nanotechnology, Theory and Practicals. He has patent in his credit that a super absorbent polymer and process for preparing the same. And another one is a multi-nutrient nanoclay polymer composite and processing for synthesis of the same. And apart from that, he introduced a new interdisciplinary course that is Introduction to Nanotechnology. So, keeping in view his two meritorious things, and he has done a lot in this field, I request Dr. Mandal to please deliver his talk.
Thank you, Dr. Rai, for this introduction, and I would like to thank the Academy of Natural Resource Conservation and Management for giving me this opportunity. Am I audible and my screen is visible?
Yeah, your screen is visible and you are audible both.
Okay, thank you. Good afternoon, one and all. I welcome you all to this online training program on soil health management concept and practices. So, a lot of deliberation already have been
Sir, something
there regarding soil health management and different activity.
So
We'll be
mic
dealing
is not working. It is not
basic
properly audible.
properties. Mic is not working.
Not properly audible.
Yes, hello. Now,
Yeah, now it's okay.
am I audible now?
Yeah, now it's okay. Now you are audible.
Okay, okay. So we'll be dealing. Yes. So we'll be dealing with some introductory part, then synthesis of nanomaterial, what's its effect, and how best we can use different type of nanofertilizer for management of our soil. And
I think there is some problem. You are not audible. Like a network problem or something.
Conclusion. Now, soil health. What is soil health? Water combined soil. These are different components. No. Hello?
Doctor, you are not properly audible.
Now it is okay. Now.
Yeah, but little bit problem, that's all.
No.
Dr. Nintu is trying to join again. There is some technical problem. Maybe network is not proper there. Dr. Nintu? Dr. Mandal? Dr. Mandal? Dr. Nintu? Dr. Mandal? Dr. Mandal? Dr. Mandal?
Oh, he was now say lemongrass ta magha katti
Hello,
Haan, Dr. Saab.
am
Haan, Dr.
I audible now?
Yeah, now audible.
Yes,
Now,
I don't know what problem is there.
now you are audible.
Yes, PowerPoint is visible.
It's coming. Yeah.
Yes. Okay. So these are different component of soil health already discussed by different presenters. Now, why will be thinking of nano? This is problem that has been discussed. We are having very low efficiency of nutrients, particularly micronutrient, 1 to 5%, and consequently, our population that is suffering from malnutrition and lesser grain content with respect to zinc and iron, particularly.
I think, Dr. Saab, there is some network issue. Network is not proper there.
Hello.
Yes, Dr. Sir.
Yes, I don't know what problem is there. I think
I think there is network problem. That's why it is you are not properly audible.
okay. What you do?
Yeah.
I am just joining through another device. Please
Okay.
allow me from there.
Okay. How much time?
Hello.
Yes, Dr. Sir.
Yes, I will continue from this.
Okay.
So we're discussing about now. I am audible now.
Yeah, properly audible. Okay.
Yes. So coming to basic of nanotechnology, why we are interested in this nanotechnology and what nanotechnology is. We all know any materials that is having 1 to 100 nanometer at any dimension. That is the definition of nanomaterial that is given by United States Environmental Protection Agency, US EPA. Now, what are the advantages in nanotechnology? Basically, there are two advantages. First one is physical advantage, means with reduction in particle size, surface area will increase. And secondly, all our chemical process is surface dependent. More is surface area available, more will be the rate of chemical reactivity. So physical advantage and chemical advantage both are there. That's why we are interested in nanotechnology. If we see this diagram, lot of natural occurring molecules as well as viruses, these are already nano dimension. Some part of colloids also, our humic acid, fulvic acid, these are naturally occurring nanomaterial which is present in soil. Even amorphous material, allophane immogolite, amorphous material, these are naturally occurring nanoscale material which are present in soil. So what basically we did, that is nano composite based technology, as you see from this slide, that if we mix different polymer as well as clay tectoids, so basically we are developing control this formulation, that is the nanoparticulate delivery system. Now in this diagram you can see that there are basically three types of composite. First one is phase separated, second is intercalated, and last one is exfoliated. Exfoliated means basically clay, these are dispersed within polymer gallery and we are getting control release formulation. And now what are nanoparticulate control release formulation technology? We can see from this, basically there will be two monomer, one monomer, monomer 2. If we mix amphiphilic copolymer, then we'll mix clay and we'll be putting fertilizer molecules to this. So basically we are getting slow release formulation. Slow release in terms or fertilizer molecule that is there inside, and if fertilizer that has to come into solution, better to say ions that has come into solution, so this bond has to be broken. Basically microbial action in our soil system. So this is the heart of nanoclay polymer composite technology, where we are developing smart or intelligent delivery system of nanomaterial. As we have discussed initially that micronutrient, particularly zinc, iron, efficiency is very less, 1 to 5%. So our approach should be how best we can formulate this nutrient so that efficiency increases. Why efficiency is very less in case of micronutrient? You know that this available form of zinc is Zn2 plus, iron Fe2 plus. If we apply ferrous sulfate or zinc sulfate in soil, what will happen? This Fe or zinc being positively charged or clay colloidal component negatively charged, so positive negative electrostatic attraction will be there, and basically this nutrient that will not be available to root. That's why efficiency is very less. So through this approach, we will be putting zinc in ionic form through these polymer galleries, where clay that will act as diffusion barrier, and this nutrient that will gradually come into solution as plant growth progress. So what we'll be doing, this interaction of zinc or iron with negatively charged colloidal clay surface, that will be minimized, so that availability of this nutrient to root that will increase. Now coming to what we did with nano zinc formulation, first is nano zinc oxide particle synthesis, and second is zincated nanoclay polymer composite. This is control release formulation of zinc that we had synthesized, and we studied the different properties. Here, this is the scanning electron microscopy image of this zinc formulation, and we can see from this that this 8% clay content, 10%, 12%, and clay and nanoclay. As we increase this concentration of clay, basically this morphology is much more of porous, so cross-linking density increased. Now, through X-ray diffraction study, we studied the exfoliation. As we have discussed, that means clay, the structure that will be destroyed, and clay that will be dispersed within galleries, and basically this evidence of that, this originally this peak is there, but within this peak is absent, means clay have lost its structure. That means we have prepared your exfoliated type of composite, that is clay acts as a diffusion barrier by destroying its multiple galleries. Now control release behavior that was studied in soil, we see with increase in clay content, the rate of release was low at 60 days after incubation. Similarly, the rate of release was further low when we used nano clay. Nano clay and clay difference means clay, that is bentonite, is used. Original bentonite contains 70% nano clay, and nano clay means 100% nano size. Now, another important parameter was your biodegradability, as because these polymer-based formulation, these generally do not occur naturally in soil. So we evaluated biodegradability, means whether this product is degradable in rhizosphere in soil or not. For studied that, it was inoculated with Aspergillus and Trichoderma species, and through carbon dioxide evaluation, we evaluated that this product was degradable in our soil system. In both of the soil is evaluated. Now, this product that was tested in rice crop in field experiment, 2 years field experiment, at our farm, and with this treatment, 100% of zinc was supplied to zinc-coated nanoclay polymer composite, 75%, 50%, and nano zinc oxide that was applied to foliar spray, and it was compared with zinc sulfate, which is commonly used fertilizer, and you can see that there was significant improvement when zinc-coated nanoclay polymer composite that was used as a fertilizer of zinc as compared to zinc sulfate, and there was no effect. Effect means no inhibition effect of iron through this zinc-coated nanoclay polymer composite. So it was concluded that through field experiment also, it acts as a good source of zinc, and effect was much more as compared to zinc sulfate, significantly higher. Now, we observed this effect of soil enzymatic activity as because we can't put something in soil that affects negative way our microbial health. That's why dehydrogenase activity, that is respiratory enzyme, acid and alkaline phosphatase activity we measured, and it was seen that when we use zinc NCPC as well as nano zinc oxide spray also, rather there was increase as compared to zinc sulfate. So through this study, it was concluded that these products, they do not have any harmful effect on soil microbial community, particularly so far dehydrogenase activity, which is respiratory in nature, was concerned. Now, it was able to increase significantly grain zinc content if we compare with zinc sulfate at your 100% dose, 75% dose, as well as 50% dose. So this was effective product in increasing zinc content in grain. Now we calculated efficiency. We have already said that this efficiency with zinc sulfate, this is only 1 to 2%, but we increase this efficiency of micronutrient that can be achieved up to 23%. So it was concluded from field experiment that this product was efficient zinc delivery system, nanoparticular delivery system, which not only maintained higher available zinc in soil, but also increased grain zinc content as well as zinc use efficiency. Now another study we did with phosphorus formulation, we all know that phosphatic fertilizer efficiency is very less, within 15 to 20%. If we apply band placement, this is 20%, and to broadcast 15%. And another story with phosphatic fertilizer is, in India we produce phosphatic fertilizer, but this raw material, that is rock phosphate, that is imported. So what we did, we synthesized nanophosphorus from our Indian origin rock phosphate, that is from your Udaipur rock phosphate as well as Purulia rock phosphate, and it was characterized to different technique, that is your particle size analyzer, Zeta sizer. Definition says that less than 100 nanometer. So this confirmed that our particle that was in nano size range, because this is less than 100 nanometer. Similarly, Zeta potential, this is important characteristic so far stability of colloidal material is concerned, and Zeta potential, this value was beyond plus minus 30 millivolt. So nanophosphorus in colloidal dimension was stable, that was confirmed to this Zeta potential, and this was scanning electron microscope image of nanophosphorus. We able to synthesize, and some microporous structure was observed through this nanophosphorus, and it was tested in tomato as well as maize crop. We all know that this is one is monocot, that is your maize, and tomato, this is dicot. And if we compare, and we use this material in combination, that is a part of integrated management system, and it was observed that this nano formulated phosphorus that was able to increase uptake of phosphorus by both of this crop. So it was again proved that this nanophosphorus that we have formulated in our laboratory through Indian grade rock phosphate, that was effective phosphatic carrier. Now another study we did with nano iron formulation. So basically 3 type of nanoparticle synthesis mode we followed. First one was applied through biological synthesis, then chemical synthesis, and third one through nanoclay polymer composite based synthesis. Now we'll see this what was the nanoclay polymer composite. The mechanism was same as we have discussed in case of zinc. So basically we use one monomer, another nanoclay used. So there was linkage of silicon oxygen bond of clay as well as hydroxyl of clay with this polymer matrices, and basically we use iron sulfate, ferrous sulfate as a carrier of iron. So this iron that was entrapped within this polymer galleries, we can see from this. So if iron has to come into solution, so this bond have to be broken. In this way, we could able to successfully trap ferrous within this nanoclay polymer composite based system, so that interaction of iron Fe2 plus with negatively charged colloidal clay surface that was restricted. So automatically this was the principle of minimum interaction of Fe2 plus within this FeNCBC, so that interaction with clay that will be minimum. Now the scanning electron microscope image of first one is chemically synthesized, second one is first one is biologically, second one chemically, and last one is nanoclay polymer composite based system. There was changes in morphology. All these cases, these were spherical, but in case of biologically synthesized material, we use bacteria culture, and that was somewhat protected with this protein coating. And particle size analyzer confirmed that the size was less than 100 nanometer, that is in nano size range. Our definition says that something at least one dimension less than 100 nanometer is nano. So our chemically and biologically synthesized material that was in nano range, that was confirmed through particle size analysis, and this was studied with respect to iron sulfate in laboratory control based experiment in alluvial soil as well as calcareous soil, and both of the cases this iron NCPC that shows control release behavior as compared to ferrous sulfate. Now you see this effect of different iron carriers on DTP acceptable iron content, particularly in alluvial soil as well as in case of calcareous soil. For both of the cases, your nano formulated treatment that showed significantly higher result as compared to ferrous sulfate. This is treatment 2 conventionally used, and higher was in case of iron containing nanoclay polymer composite. It was most effective carrier in maintaining higher DTP extractable zinc content in rhizosphere. And iron uptake that was significantly improved with all carriers as compared to ferrous sulfate for your 25% as well as 50% reduced dose. So iron application to FeNCBC at 1/4 of dose as compared to ferrous sulfate, that is dominantly used iron source. So it was more effective as compared, even when we reduce dose up to 1/4, that is 25% of recommended dose to ferrous sulfate. Now, when we compare the efficiency of iron, so maximum that was reported in case of when this chemically synthesized material that was applied through foliar spray as well as biologically synthesized material as compared to soil application, foliar application was most effective in increasing the efficiency of iron content. Now another study we did with manganese. One of our students, he did impact of manganese nanoparticle. We synthesized 2 type of manganese nanoparticle. First one is nanomanganese dioxide and second one is manganese NCPC. So NCPC mode of system that was again applied to manganese and nano manganese dioxide that was chemically synthesized nanoparticle. And it was characterized through scanning electron microscope. You can see generally fractured morphology that was observed in NCPC. Also, this morphology we observed some sort of polar structure. Now, this chemically synthesized nanomanganese dioxide particle size was less than 100 nanometer, so it was confirmed it was in nano size, and it was tested in wheat crop in a pot experiment. And you can see that through this NCPC, we can increase this content in grain as well as straw content as well as total uptake. So when we computed the fertilizer use efficiency, particularly agronomic apparent manganese recovery, it says that we can increase this manganese use efficiency up to 31%. So conventionally, in case of micronutrient, we know that efficiency is within 1 and 5%. So this manganese nano carrier, this was able to increase efficiency of this manganese up to 31%. So through different zinc, manganese and phosphorus nano formulation, we can conclude that in case of zinc, DTP acceptable zinc was highest in case of zincated nanoclay polymer composite, and it maintained higher content 1.97% milligram per kg. Grain zinc content was also higher at 100%, and maximum apparent zinc recovery was recorded when we applied zinc to ZNCBC up to 23%, and zinc NCBC was found to be effective zinc carrier in case of rice rhizosphere in field experiment, and there was no negative effect on soil biological health. As evidence, we measured soil enzymatic activity, particularly dehydrogenase activity, as well as acid and alkaline phosphorus activity. So for manganese fertilizers, nano manganese dioxide foliar application that was effective, and nano manganese NCPC through 1/4 of recommended dose that was effective in increasing efficiency up to 31%. This was result in pot experiment with wheat only. Now, iron nanoformulations, iron NCPC that recorded 4.47% iron content, and iron application to NCPC that maintained significantly higher content of DTP acceptable iron content in soil, and 25% of recommended dose to NCPC recorded statistically at per effect with ferrous sulfate. And there was no negative effect on soil enzymatic activity. We measured in case of iron dehydrogenase activity, acid alkaline as well as UAS activity. Rather, there was stimulation. So future scope of research in this direction that we could synthesize and evaluate zincated nanoclay polymer composite, different grafted composite, manganese NCBC, iron NCBC as well as nanophosphorus. We evaluated effect of zinc formulations up to field experiment in rice wheat cropping system as well as nanophosphorus, but manganese NCBC as well as iron NCBC that was tested in pot experiment with rice and wheat crop, but that need to be tested in field experiment in a long-term basis, so that what will be the effect of this nanoformulation in crop, in other soil health. We'll get a realistic picture if we evaluate this formulation in long-term basis in diverse soil type. So these are a couple of publications we able to publish through our work. This paper appeared in Polymer Plastic Technology, another is Reactive and Functional Polymers Journal, then again Polymer Plastic Technology and Engineering, we could able to publish zinc NCBC result in wheat crop in European Journal of Soil Science. Another in our work with zinc NCBC in field experiment, we could able to publish in soil and tillage research. So couple of good publication to our work and agricultural research on biological parameter. And at last, I would like to acknowledge actually I started working on this nanoformulation during my doctoral research program at IARI. I worked with zinc, and afterwards in our Bihar Agriculture University Sabur through postgraduate research as well as project, we could able to continue different type of nanoformulations. So I'd like to thank my doctoral guide as well as master's guide from Indian Agriculture Research Institute. And whatever I have presented, Mr. Samrat, he worked on zinc nanoformulation in field experiment. Mr. Dubey, he worked on in combination of nanoformulations as well as your zinc solubilizers on biological parameter. One student, he worked on this hybrid nanocomposite. Another student, he worked on iron NCPC, iron-based nanoformulation. Another student worked on manganese nanoformulations. Another student worked on effect of iron on manganese, iron and zinc formulations on microbial resistance and resilience of soil. So I'd like to acknowledge my university, that is Bihar Agriculture University, its authorities as well as our departmental colleague and head of department for providing all sort of facilities for carrying out this sort of work and at our nanoscience and nanotechnology unit here. So thank you. This is the end of this presentation. Now I'd like to interact and take some questions from participants.
Thank you, Dr. Saab. And you have given a very detailed lecture about the newer technology, and you have done a wonderful job. Even the students under your guidance is doing wonderful work. So, any query, any question? If anybody want to ask any query question, they just first unmute them and then ask the question. IR put their question on the chat box.
Hello.
Yes.
Yes.
Hi, Anitu sir.
Hello.
Sir, actually, I have a query.
Yes.
Sir, since long, sir, you know that zinc biofortification, sir. Actually, we are trying to improve zinc on the grain of rice. Actually,
Yes.
till now many research has been there, but we are the zinc uptake is there, but it is more in straw. But our main concern should be to grain. So, sir, I want to ask you that whether with the help of nano fertilizer, whether can we improve exactly in rice grain zinc? Can you improve it? And if you can improve, what will be the exact formulation for that, sir?
Yes, you see, I have already presented, we tested our developed product, that is zinc containing nanoclay polymer composite. This is one shot of control this formulation of zinc, and it was tested in field experiment in rice crop. It was effective in increasing grain zinc concentration, as well as we could get efficiency, but that is agronomic zinc recovery up to 25%. And if we apply another formulation, that is nano zinc oxide, that is only mode of application is foliar spray. Again, it was effective in increasing grain zinc concentration. So we have documented this effect through field experiment here. Definitely that zinc grain concentration that can be increased through this formulation. Yes, Mr. Nath.
Hello.
Hello.
Hello. Anybody else?
Hello, sir. Yes. I wanted to ask, so doesn't the nanotechnology like nanofertilizers decrease the productivity of soil,
No,
or do they increase? And if they increase, doesn't it contaminate the soil?
no, that's why you see, for all of our cases, we work with zinc nanoformulation, we work with manganese, phosphorus, as well as iron nanoformulation. And for each of the cases, we evaluated the effect of this formulation on microbiological parameters, particularly in rhizosphere. At first, we evaluated this effect of this formulation on dehydrogenase activity, that is respiratory enzyme, then acid alkaline phosphatase activity, as well as we have counted the number, that is plate count of bacteria, fungi, and actinomycetes. In none of the cases, we could document any negative effect of this formulation in rhizosphere. So when you will be working on nanoformulations, not only this formulation, whichever we have worked, any sort of nanoformulations, basic studies we have to do is, that is dose response curve. Dose response means optimum dose selection. This is very important. Say if we increase nano zinc oxide at very high concentration, so instead of getting your good result, you may not get good result. As we get, what happens if we apply nano zinc oxide at very high concentration? So size is less, so more or maximum of root hairs that will be surrounded by nano zinc oxide particle at very high concentration. So this diffusion, that process, that will be restricted. So instead of getting good result, so you may not get good result. There may be some suppressing effect also. So you have to optimize the dose. So for our studies was concerned, none of these cases we could not documented any negative effects so far soil biological health was concerned.
Okay, thank you, Dr. Sir.
Thank you. Anything else?
Anything else? Any from anybody's side?
So,
Yeah.
Yes.
so if this nanofertilizer is used for a very long time, so is that affect the soil or contaminate the soil?
He just
No,
answered
that's
that.
why.
My question was also that. So he already answered that. You have not heard that one. So
Yes, that was already discussed.
yeah.
For a very long time. I mean, like 10 years, 15 years from now.
No. It is not. If you use that optimum dose, so optimization of dose is very important.
Hello, sir.
Yes.
So I have one query, sir. Actually, myself, G. Manish Shankar. I am doing PhD in Vishwabharati Central University, West Bengal.
Yes.
Okay.
I have a query is how to study the release pattern of actually this nano formulation, sir. It actually totally different from commercial to this nano formulation, na, sir? How to study the release pattern?
Yes. If you have seen my presentation at first, what we did, we had formulated this product, then characterized, then control release study. We have studied in laboratory incubation experiment. Say you have formulated zinc or iron, whatever product. What we have to do, you have to take your dominantly used zinc fertilizer, that is your zinc sulfate heptahidrate. Then one treatment you have to keep as control, that is without zinc. Then your nanoformulated, that is, say in our case we have used zinc NCBC or nano zinc oxide. So set of 6 or 7 treatment will be there. Then for studying control release pattern, you have to take reading of DTP acceptable zinc, iron, copper, all this thing content at say 15 days interval, at 15 days, 30 days, 45 days, 60 days. Okay. Then you have to plot in your x-axis days after incubation, in y-axis is zinc release. Okay. In this way, you can study the release pattern. This is very important. Until and unless you study release pattern, how could you say that this is your control release or not? Now, when you'll be studying the release pattern, what will happen? Say when you have used zinc sulfate, this soluble salt, na?
Yes,
in
sir.
soil water, Zn2+ ion will be there. clay is having negatively charged. So clay negative and Zn2 plus, this is positive negative interaction will be there. So at initial days only, maximum of iron that will be released from your zinc sulfate, zinc, and afterwards, say your 30 days, 45 and 60 days will not be getting your release through your zinc sulfate. But in case of controlled release formulation, it will be getting your increase in DTPA zinc up to your say 60 days that I have presented already. So control release study that can be done through your laboratory incubation experiment only.
Okay, sir.
Clear?
Yes, sir. Clear.
So that is good. It's nice to interact and answer.
No, it's a very nice presentation, sir, and maybe many who among the participants, whoever want to work on that aspect, can separately discuss with you.
Yes,
and
yes.
It's very interesting and not a burning topic. So thank you,
Yes.
Thanks a lot.
Thank you, sir, for giving me this opportunity. I'd like to thank this Academy of Natural Resource Conservation and Management and Mr. President, Secretary, Course Director, and most importantly, Dr. Anshuman Kohli for our Bihar Agriculture University for giving me this opportunity.
Definitely, Doctor. Definitely. Thank you.
Thank you, sir. So with your permission, I am leaving this meeting now.
Sure. Thank you, sir. Thanks a lot. Now, with this, our phone session has been completed. Now, again, we will meet at 2:15 for the next session with same link. So for that, all are requested to join us at 2:15 p.m. with same link. Thank you.
होगा अरे यार